Yes, I know.
Good morning, everybody. But you can see the screen. Can all hear me?
Yes.
All right. Sorry for the late start. As you know, I'm not in my usual place today. I'm actually overseas. So a little bit different. So the preparation a little bit different, and hence a slight delay. In addition to that, I'm still a little bit jet lagged from traveling, but that won't stop our class and our activities from carrying on. We're going to use the technology to make sure that it happens. This is super important. All right, so today we want to revise our inequalities and linear programming. And as usual, I will start with going over class activity that we had in our last class, which is what you have seen on the screen. And I will then go into doing a few past paper questions. We work for about 2 hours, as usual. And you are, as usual, expected to redo all examples, all the questions I'm doing here today. That is always the objective, right? But this is revision and practice. So you are to redo all the examples, all the questions that I'll do. In addition to that, you'll get a chance to see exactly how the exam questions are set, especially in recent times. Because what happens is that, the nature of the questions, they vary from year to year. They vary in periods. I think it has to do with who is setting the exam paper. So depending on who is setting the exam paper, you might find that the questions are structured a particular way. And even me as a teacher, sometimes I will know that the person who's setting the exam paper is somebody different, because the way the questions are set out, you can clearly see that it's different. There are many different ways to set questions, right? And sometimes the main objective of a question is tested differently. And some person might focus on one main objective from another. So sometimes the questions are set out depending on who is writing the question. But they all cover the syllabus, and you should still be able to do all of them, because the core content doesn't change. All right? All right, so it's always important for us to look at the past papers, especially the more recent ones, because those are the ones that will be more likely to be aligned with the way the question will be set on your exam that you're doing. All right, unless somebody new come and set it. But then even if somebody new come and set it, you still will be able to do it if you fully understand it. And so that's why you have to practice a whole lot. The more you practice, the more you understand, and the more able you are to answer questions regardless of how they are set. All right, so let's get into it now. So this was the first question here. It's a simple inequality, right, that we are doing. This one, first part, is to solve that. And what I say is that solving this is the same steps as if you're solving with an equal. X minus 3 equals 3x minus 7. So it's nothing to it really. There's only really one significant thing to the inequality, and I've repeated it multiple times. If there comes a point while you're solving, remember, solving means you're trying to make x the subject. That is the whole aim of solving. You're trying to make the unknown the subject. And in this case, the unknown is x. we want to get x alone on the left side and then some inequality sign and something on the right side. You want to see what x is equal to. But this case is not equal because it's an inequality that you're solving. So I'm saying now, for this one, if there comes a point in solving that where you have to multiply or divide with a negative number, you have to remember to reverse this inequality sign. So it is less than now. If there comes a point when you have to multiply or divide through with a negative number, you have to remember to reverse inequality sign. You know, for an inequality to remain true, the inequality sign has to be reversed when we multiply or divide with a negative number. And that was one of the core main things of the week that we did. Because it is something that you have to remember yourself. There's no hint, there's nothing on the exam paper that will help you to remember that. So it has to be something in your head, something that you have to know and carry with you once you're dealing with inequalities. That's one of those special things about inequalities that you must remember and you must know. Once you're going to divide or multiply with a negative number, you have to remember to reverse the inequality sign. All right, so let's go ahead. I'm going to do it two ways for you. I'm going to do it one way where there comes a point where we have to divide with a negative number. I'm going to do it another way where we did not have to divide with another number. But the steps in solving it is really the same as this in terms of transposing and making x the subject. All right, so we'll do this one, the inequality. All right, so let's do it two ways. I'm going to do it two ways. Let's see if I can put them side by side. All right, so let's go. All right, so we're solving x minus 3 less than 3x minus 7. And let's say I want to group the x on this side of the inequality, on this side. I want to group the x on this side of the inequality. So it means that I want to take this x over this side. If I remove the x on this side, I'll be subtracting. It's the same as saying subtract 3x from both sides. And this 3, this negative 3, I would not want it there. I'd want it on the right side. So I would have to transpose it over here. All right, so let's go step by step. When I transpose this over onto this side, right, it's going to become negative 3x. I'm going to end up with x minus 3x. The sign does not change, so it's still less than. This negative 7 is on the right side. It's going to stay negative 7. And then this negative 3, when it comes over on the other side of the inequality, just as though if it comes on the other side of an equal sign, it changes sign. So it becomes a positive 3. It is the same as saying add 3 to both sides. Now, be careful with these negative numbers now, the negative in here. So it is x minus a negative 3. So it's same as saying 1 minus 3, really, right? Or similar to saying 1 minus 3, which would be negative 2, but then you're using x. And so it's negative 2x that we are getting. So it's like 1x minus 3x is negative 3x. This is like 1x minus 3x is negative 2x. It's become the negative 2x. So the sign remains less than, and then this is negative 7 plus 3. Negative 7 plus 3 is negative 4. And I've seen some persons still having a challenge with doing stuff like that. All right, this is something that you have to work on. These negatives and positives, adding, subtracting, multiplying with negatives. Something you have to practice, work on, do them repeatedly. All right, so here now we want to make x a subject. So essentially to make x a subject, we need to divide this side by negative 2 to get rid of it. And if we divide that side by negative 2, we have to divide this side by negative 2 as well. And so to go to the next step to make x a subject, we are dividing with negative 2. That's a negative number. And so let's write it. We're going to divide by negative 2 as our next step. And if we divide by a negative number, we have to remember not to reverse the sign. So I'm going to write it here. Divide by a negative number. So because I'm dividing with a negative number, I have to reverse the less than sign. The less than sign. All right. So let's go now. So when I divide this by negative 2, it becomes x. I have to reverse the sign and make it greater than. And then this becomes negative 2. That's negative 4 over negative 2. The negatives will cancel, and 4 divided by 2 is 2. Let's put back what was there. So essentially, if I divide this by negative 2, it's going to become a positive 2. And so this is my solution. That's my answer for that inequality. Let's do it another way where I group the x values on the right side instead and see what happens. So this is my solution right now, and that's my answer. X is greater than 2. All right. Let's do it the other way where I'm grouping the x values on the right side now. So I'm going to write by the same inequality. X minus 3 less than 3x minus 7. This time I'm going to bring the x over onto this side, because let's say I'm trying to group the x on the right side this time. So this 3x is over here. It's not going to move this time, so it stays 3x. When this x goes over onto this side, it's going to become a negative x. Negative x. Negative x. And then this 3 is negative. It stays there on the right side. And this negative 7, when it comes over here, it becomes a positive 7. So I'm going to put the plus 7 in front here now. Positive 7. It's a positive 7, but I don't need to show the plus. Right? I'm putting it at the front. Then this 7 minus 3 is just 4. It's less than. This is now 3x minus x. 3x minus x is just 2x. So this is just 2x. And so now I have a case where I need to make x alone on the right side. Let's not call it the subject just yet, because usually the subject is on the left side. But to leave x alone by itself, I have to divide by 2 and divide this side by 2 as well. So this time I'm dividing by a positive 2. So let's write it. I'm going to divide by a positive 2 this time. So in this case, I'm dividing with a positive 2. I don't have to put the plus in front of it. But because I'm dividing with a positive number, no need to reverse the sign. Let's write it this time. No need to reverse the less than sign. Why? Because I'm dividing with a positive number. The only time you reverse the inequality sign is when you multiply or divide with a negative number. This is a positive. And so this less than sign is going to stay less than. All right, so let's go now. So this 4 divided by the 2 is 2. The sign remains less than. This 2x divided by 2 is x. So this is also my solution. But remember now, an inequality can be read both ways. If I read it this way, it is saying 2 is less than x. But if I read it this way, it is also saying that x is greater than . If I read it from right to left. Reading from right to left, that's what it is saying. X is greater than 2. And so it means then I can just turn this around and it will become the same as that. Because if I write it as the same this way, I can therefore also write it x is greater than 2. Because the inequality can be read both ways, both directions. So if I write it as what this is saying, reading it from right to left, then I can write this. And what you're finding is these two solutions are the same. This one and that one is the same. All right. So that is it. Everybody okay with that? Everybody okay with that? Any questions?
Yes, sir.
Yes, sir. We're okay.
All right, good. The part 2 now is asking us to draw the number line. Draw the number line, and also we have to write down the solution set. All right, so we have to draw the number line and write down the solution set. So let's go on the next slide. And we are working now with the solution, which is x greater than 2. So the number line is just a normal number line, and you have to put your inequality on the number line. All right, so I'm going to draw a line. I'm going to put in 0, 1, 2, 3, 4, and then -1, -2, and so on. So now 2 is a critical value. 2 is your starting point for the inequality. Just that there's no equal on the inequality. So you don't really want x to be equal to 2, you know, but still you have to indicate where you start. Starting point is 2. So you're going to put a circle on the 2. That's a standard way to do it, guys. One student in the class gave me this, and then went that way. No. Put it the standard way. Don't try to reinvent the wheel. You put a circle on it, on the 2, to indicate where you're starting. Now that circle is unshaded because there is no equal there. I leave it unshaded. Then because I want values greater than 2, I indicate that by putting an arrow to the right, because values over here are greater than 2. And so I can write inequality now, x greater than 2. That is the number line. Now, if this inequality instead was greater than or equal to, let's say we had a greater than or equal to, then the difference is that I am including the 2. X is now 2 or more in this case. And to indicate that that 2 is also a part of the solution. The difference now is that I would shade this circle that is on the 2. So that shaded circle on the 2 is a way of saying 2 is included. So my inequality, instead of x greater than 2, would be x greater than or equal to 2. Means 2 would be a valid answer. 2 is a value that x can take if it was this. But what we just did, that's not it. So let's reverse what we did. So that is a correct solution. There is no equal on the inequality sign. So we indicate that by putting an unshaded circle there. The unshaded circle there means that 2 is not included. We only want values greater than 2. So a value, for example, of 2.0000000001 is good, because that is greater than 2. But 2 is not good. X cannot be 2. It can be any value greater than 2. No matter how small more than 2 it is. Once it is greater than 2, it is valid. All right? So that is how we indicate that. All right? And that is inequality for that one. That's a number line. They also wanted us to write down the solution set right here. So the solution set, I always say, is just basically putting the solution in set brackets. So the solution set, this is a number line, as you can see. The solution set is basically putting this solution inside set brackets. And you just write the set brackets. These are how you write the set brackets. And you say x is such that, and you put this inside there. Same thing. It's not complicated. X is greater than 2. And so that will be our solution set. Simple as that. All right. Put it inside the set brackets and you write that thing there. Put the same thing there. And you just make sure you add x is such that. All right. And then the third part now said, the third part here said, and this is something that I like to do in CXC. I like for you to pick out a value. It says if x is an integer, determine the value of x, right? Determine the smallest value of x that satisfies the inequality, the smallest value that x can be. All right, now remember, what are integers? Integers are whole numbers, positive or negative whole numbers. So it means that we're not using a value like 2.5, because that's not a whole number, right? So we only want the whole numbers, and the whole numbers are usually what's on the number line. So like the 3 and the 4 and so on. All right, so if I was to list the values of x for x greater than 2, and we want the integer values, then x would be equal to, it would not include 2. It would be 3, then 4, then 5, then 6, then 7, and so on. Those would be the values of x if I were to list them, if they were whole numbers only. Integers, those would be the values based on this solution. You can see it on the number line out here as well. And so the smallest one would be 3. So our smallest integer x, smallest integer, if x was an integer, x would be 3. The smallest one would be 3. Cannot include 2 because x is greater than 2. So cannot include 2. All right, but go to that. We'll move on.
Yes, sir.
But okay.
Yes, sir.
All right, so that completed the first question. All right, so if you hear the dog barking, I'm in a place where I have a dog, actually my daughter's dog, and so it's not, you sometimes have to make his voice be heard. So Let's excuse the barking for today, please, if you hear him, okay? All right. Let's continue now with the second question. All right, so this second question now is our typical linear programming questions. Truth be told, they don't really set the questions this expansive anymore. This is in the past when a linear programming question would be a whole question on exam paper. Now, it will either be a part A or a part B of a question. And so they are not this expansive, that not so many parts asking so many things anymore. And we're going to see that when we start to look at the past paper questions. Occasionally, they might give you one that have a lot of parts, but in the main, they're not this expansive anymore, not so many parts. All right, but if we can manipulate and do these that have this many parts, then we'll be able to do the ones that they most set in recent times. I think there was one recently, maybe 2022, that was a little bit more than the recent. No, let's put it that way. All right, I was kind of surprised to see that one having so many parts, but for the past 10 years or so, they have not been that expansive. But it doesn't matter. Let's practice with these so that whatever we get, we'll understand and can master it. All right, so this is an application topic. Linear programming is an application topic for the use of linear inequalities on a graph, and in particular, simultaneous linear inequalities on a graph. And when you draw linear inequalities on a graph simultaneously, you usually get a region that satisfies all inequalities. All right, because remember, inequality on a graph is about a region that is either above the line or below the line, above or below, not both. The line is the equal mark. So the y equals on the line, for example, is the equal mark. But y greater than is indicating the region above the line. Y less than is indicating the region below the line. All right, and I'll explain as we go. All right, so this question says a shop stocks X radios and Y phones. So the first thing I want to point out is what is X. X is the number of phones, a value, just that we don't know what it is. And Y is the number of radios. So in your mind, you should be saying number of phones is X, number of radios is Y. All right, so they're stocking X phones and Y radios. It has shelf space for up to 20 devices. Now, the word devices here is taken to mean the phones and the radios. All right, and so the total of the phones, total of the number of phones and the number of radios can be only up to 20, can't pass 20. So it's either going to pack all 20 devices on the shelf or less. The shelf can hold no more than 20, because that's the shelf space that you have. So let's write this down now. So X is our number of phones. I'm going to write X phones just for information. And I'm going to write Y radios. So I have it right in front of me. Y radios. So X is the number of phones, Y is the number of radios. And the total devices that you can pack on the shelf is X plus Y. You're going to put X radios and X phones on the shelf and Y radios. And so the first inequality is that X plus Y, which represents the total devices, the number of phones plus the number of radios, these total devices, has to be less than or equal to 20. You cannot put more than 20 on there. So it's either going to put all 20 on there for the equal, or you're going to put less than 20 on there for the less than. So this is the inequality representing the first condition. It's a limited. The inequality are for limitations and constraints. The constraint here is that you cannot put more than 20 on the shelf. All right. All right. So the second part of the information here is basically saying that the owner of the shop spends $150 to purchase each phone. So it's $150 for each phone, and $200 for each radio. So let's see if we can put that on the screen and capture it here. So in terms of the cost that he spends, in terms of cost, right? For the phones is $150 $150 each. And for the radios is $300 each. That means for one. Each means for one. So $150 for one phone, $300 for one radio. So if you're buying X phones, then it's X times 150 because you're spending 150 X times. And if it's Y radios, then one is Y times 300 because it's Y radios you have, and for each of them is spending 300. So the total you're spending is 150 times X plus 300 times Y. In this case, they are saying that she has $4,500 to spend on the purchase of the devices. So it's like she goes there and she only has this amount, $4,500 to spend. You cannot spend more than you have. So the total spend is going to be less than or equal to 4,500. Less than or equal to 4,500. All right, you cannot spend more than you have. All right, so the amount spent, let's look at the inequality now for part 2. The amount spent, which is 150x, that's for the phones, plus 300y, that's for the radios, must be less than or equal to the amount that you have, which is 4,500. If you notice, I've left off the dollar sign. I can put it there, but I don't need to show it because everything is in dollars. So that is inequality for that information. That is inequality. This is the total amount spent. $150 times X on the phones, $300 times Y on the radios. That amount must be less than or equal to the total that she has to spend. Cannot spend more than she has. All right, so that is that. But this now can be simplified by dividing through by 150. You should always do that. Divide by 150. And if you divide by 150, then this becomes X. Divide each term by 150. This becomes X plus divide this by 150. That becomes 2y less than or equal to divide this by 150. This divided by 150 is 3. So we get 30. That is the second inequality. That is the second inequality. All right. Better go to that.
Yes, sir.
All right. All right, good. All right. Then we come now to the third piece of information here. It says the owner decides to stock at least 5 phones. At least 5 phones. Let's mark it. At least 5 phones. That means 5 or more phones. At least 5. And at least 5 radios. That means 5 or more radios. Now remember, the number of phones is X and the number of radios is Y. What this is saying is that the number of phones must be 5 or more. So let's write that down. Part 3. The number of phones, which is X, the number of phones, which is X, must be at least 5. At least 5 means 5 or more. It means it must be greater than or equal to 5. And similarly, there must be at least 5 radios. And so Y, which represents the number of radios, must be 5 or more. That means greater than or equal to 5. So those are your next 2 inequalities. So if we're to just asterisk the inequalities that we have to focus on, let's asterisk them in purple. It will be this one, this one, this one, and that one. So we have 4 inequalities that will have to satisfy all this information. All right, good. So the next thing is for us, well, that was the 2 inequalities. The next thing now is for, let me first ask, is everybody good with that? Everybody understand these 4
Yes, sir.
inequalities? Everybody
Yes,
okay
sir.
with them? All right, good. So the next thing we have to do now is represent these inequalities on a graph. And we did cover how we represent them on a graph. And these are all associated with lines. This is associated with a line. This one is associated with a line. These two are associated with lines. Remember, inequality on a graph is about being above or below a line. So you either want the region above a line or below a line. The next thing is that that line can be broken or it can be a solid line, depending on whether or not the equal is a part of inequality. So just like in the number line up here, when we did the number line up here, the unshaded circle means that you don't want the value. When you draw a line and the equal is not there, you're going to put a broken line when the equal is not there. But if the equal is there as a part of the inequality, it's an indication that the line is valid. The points on the line are valid points. In that case, you're going to be drawing a solid line. All right. So here, they're telling us in part B, that to use a scale. Well, this one says the scale, the graph was scale. So I gave a scale graph. So the graph has been scaled 2 units to 5 dividers on each axis. And we're to draw the lines associated with the 4 inequalities. Then we were to shade the region which satisfies the 4 inequalities. Then we were to state the vertices of the shaded region. And the vertices, as you know, are very important points because they are the points you go when you want to maximize or minimize any function in a formula connecting x and y. It's where your extreme values are for the x and y. All right, so I'm going to put those inequalities on the graph right here. Here it is. All right, so the first one now, the thing is, how do we represent this one on the graph? Let's put it right beside it. Now, firstly, I always say the less than sign means that you want below the line. Now, first, the equal is there. And so because the equal is there, at a part of the inequality, means that the line is a part of the inequality. And so you're going to draw a solid line. The less than means that you want below the line because the y value on the left side of inequality is positive. When the y value on the left side of inequality is positive, the less than means below. So I'm going to write that from now. We're going to write below, means that we want below this line. So the region we're interested in is going to be below the line. The line is going to be drawn solid because of the equal, meaning that the line is a part of the inequality. It's going to draw a solid line. And the line is withdrawing is the one that's associated with that inequality. The line associated with that inequality is obtained by simply putting an equal where the inequality is. So the line we're talking about then is the line x plus y equals 20. And that's one of the easy lines to draw. It's a line that will cross the y-axis at 20 and also cross the x-axis at 20. If the line is, for example, x plus y equals n, it means that that line will cross the y-axis at a value n and also cross the x-axis at a value n, and will stay like this. So whatever that value is, that's where it crosses the y-axis and that's where it crosses the x-axis. All right, simply because on the y-axis, the x value is going to be 0, and if the x value is 0, the y is n. And on the x-axis, the y value is going to be 0, and so the x will be n. All right, so I've shown that in the class. So it's one of those easy lines that you need to remember. All right, you don't have to work. The more things you know, the better. So this line will pass through 0, 20 on the y-axis and 20, 0 on the x-axis. So that's an easy line to remember. 0, 20, and 20, 0. Then we come to this inequality. We have to represent that one on the graph as well. So let's put it here beside it. What we're going to do. Now, again, the y on the left side of the inequality is positive. And so the less than means that we want below the line. We are interested in the region below the line. So we're going to put the word below. And this that I'm doing in purple, you don't have to actually write it on the exam paper. It's just the chain of thought that you must have to do it on the graph that I'm writing out in purple. You don't have to write this out in purple. You can just go ahead and do it. But this is what you must be thinking. All right. And then because the equal is a part of the inequality, you're going to draw a solid line, a line that is not broken. If the equal was not there, you would have to draw a broken line. But because the equal is there, you're going to draw an unbroken or a solid line. The solid line means that points on the line are valid points. And then the line that we're drawing is the one associated with this inequality. Again, is obtained by changing this to an equal. That's why you get the line that is associated with it. And so it is x plus 2y equals 30. That is the line that we want. And then now, how can we quickly get 2 points on this line? We want to do it as quickly as possible. And a way to do it quickly is to say, okay, we're going to put down 2 points. 1 point we're going to put on the x-axis and 1 point we're going to put on the y-axis. So we're going to mark 2 points. For the first point, here I'm going to give an x value of 0. So it means that I'm using a point on the y-axis. For the second point, I'm going to give a y value of 0. And then now it's a matter of determining what y value must go here and what x value must go here. This equation will tell us, because if we put 0 for the x, it's like we have eliminated the x. And so we are left with 2y equals 30. If 2y is equal to 30, then clearly you divide by the 2, the y is equal to 15. And so I'm going to put 15 right here. So that is a point on the line, 0, 15. And that point is on the y-axis. And then for this point to the y equals 0, it's like we put this 0 for the y value here. And then 2 times 0 is 0. And so it's like to eliminate that 2y. And so clearly then the x is now equal to the 30. X is equal to the 30. And so when the y is 0, you can clearly see that the x is 30. I'm putting the 30 there. And so these are 2 points on that line. This one is on the y-axis. This one is on the x-axis. And so those are 2 points I can quickly use to draw this line. And then we have this line now, this inequality now. And this one means above, because the greater than is there. So if x is above, remember we want above a line or below a line, above. Again, the line is solid because the equal is there. So I'm going to write solid. And the line we're drawing is x equals 5. The one associated with this line is x equals 5. I must know that the x equal to a number line are vertical lines. So I'm going to put a line like that to remind me that it's a vertical line. The y-axis is x equals 0. The y-axis on a graph is the line x equals 0. So lines that are x equals a number will be vertical like the y-axis. So my x equals 5 is going to be a vertical line. Then for this one, I'm going above again. The y value is positive, so the greater than means above. Again, for this one, I'm going above this line. I want above the line. I also want the line because the equal is there. And to show that I also want the line, I'm going to draw it solid, because the equal is there. And the line this time associated with this inequality is y equals 5. And y equals 5 is a horizontal line. I'm going to put this to remind me that the y equals 5 is a horizontal line. And to remember that, we can remember that the x-axis is the line y equals 0. So lines horizontal like the x-axis will be y equal a number like this one is. So y equals 5 is horizontal like the x-axis. So that's how we can remember these things. But with practice, you will know. You won't have to depend on memory. You will know when you practice a lot. All right. So these are the in purple are what I'm going to indicate on the graph. These things. All right. And as I said, you don't have to write out these things in purple on the paper. All of that, you don't have to write it out because it takes time to write it out. But if you're thinking these things while you're doing the question, then you'll be doing the right thing. All right. So the first line here now is the one that passes through 0, 20, and 20, 0 for this line. So I'm going to mark it on the graph. Remember, I won't be able to draw the line straight, guys, because I don't have a ruler. And the app that I'm using does not allow me to draw a line straight. All right. So I'm putting the point here for the 0, 20 and has to be precise. Remember, somebody draw it and draw it right beside the point like that. No, it must pass through the correct point to give you a graph. And the point on the x-axis is 20, 0. So I need a straight line passing through those 2 points. So you use your ruler and you draw the straight line through those 2 points. All right, so it's supposed to go something like that. Just not have a problem drawing it straight. Then you label the line with the equal sign. I told students, do not put the inequality on the line. You have to put the equal on the line. Label the line with the equal sign. The line is the equal mark. Above the line is for greater than. Below the line is for less than. The line is y equals. The line is y equals. So when you label the line, you're labeling the line, you label it with the equal sign. So you label the line y equals, not y equal, label it with equal sign, not line, not y equal, x plus y equals 20, x plus y equals, I'm using the equal, x plus y equals 20. And then now to remind me that I want below the line, I'm just going to put the arrow pointing down. So it means that the region that I want is below this line under here somewhere. All right, below the line. All right. So let me show you an example of where y plus y we want below the line. So take a point here, for example. Take a point here, for example, here, which is below the line. All right, right here. So this point, the x value is 5 and the y value is 10. So if you add the 5, if you add the x plus y, it will be equal to 5 plus 10. 5 plus 10 is 15. See, 15 is a value that is less than 20. That's why this point satisfies this inequality, the inequality we're trying to represent, x plus y less than or equal to 20. Right? But on the line, this point will be 5, 15. And so the x plus y would be 5 plus 15, which is equal to 20. And so that is all points on the line are valid because it satisfies the equal part. But below the line, like here, it will get in 15. And 15 is less than 20. We will add the x and y value at a point below the line. They add to a value. In this case, 15, and 15 is less than 20. That's why region below the line satisfies the inequality, satisfies at least the less than part of the inequality. Can we understand that, guys, and appreciate that? Do we understand that? Understand that, yes, students? Sir. Okay. All right. So next one we're going to draw now is for this one, the second one. And we worked out these 2 points for the line that we're going to draw. So this point is on the y-axis. It is a y value that is 15. So you can't go put 15 on the x-axis. It is a y value that is 15. So the x value is 0, the y value is 15. So that point is right here. That point is right here on the graph. And the other point that we have is 30, 0 over here. And so that point is out here. 30 is the x value, 0 is the y value. So it is the point right here. And so we need a straight line passing through those 2 points now to get the second line associated with this inequality. Straight line through those 2 points. Again, I cannot draw it straight because I don't have a ruler on this app, but I'm just going to draw it to my freehand the best way possible. It goes like that. And then again, you have to label the line with the equal sign. The line is the equal mark. So I'm going to label this line x plus 2y equals 30. I'm going to put the arrow below this line as well because it was below. There it is, below. So it means that the region that I want is below this one and below this one. So I know that I want somewhere down here so far. I'm just not going to shade anything yet until I'm done. I have 2 more lines to put in. All right. Then the next line I want is a line associated with this inequality, which is the line x equals 5. Now, as we said, x equals 5 is a vertical line. That's why we put this indicator here to remind us. This is 5. I want to draw a vertical line through there. So we're on this line right here. X equals 5, this one. Label the line with the equal sign. I'm going to put x equals 5 at the top here. I'll put up arrow to the right because we want values of x to be greater than 5. So it means that we're coming to the right side of this line where x values are greater than 5. All right. And so the region that I want is somewhere now below this line and to the right of this, but we're not done yet. We still have to put in the last line, which is the line for the inequality y greater than 5. That line is y equals 5, and we want to go above that line. So y equals 5 as indicated here is a horizontal line passing through 5. And so this is y equal, this is a 5. We're going to put a horizontal line through here now. And label the line with the equal sign. Remember, I'm not able to draw straight lines. You have to draw it straight with a ruler. This line is y equals 5 and put an arrow on top to show that I want above the line. So the region that I want is normally the region bounded by the 4 lines. And no line must pass through the region. Let's shade that region in green for you. So the line, the region that I want is here. Now let me show you step by step. I want to go below this one, above this one, and above this one. And the question says that we must shade it. So I'm going to shade it, which is inside here, this quadrilateral right here. That's the region. Now, if I made a mistake and I shaded over here as well, I should know that something is wrong because no line must pass through the region. That's a shade, because if you look at it now and look at this line right here, you'll be shading above and below it. And inequality is either you're above the line or below the line. It cannot be both sides. So that line would make that shaded region not valid. All right. So you cannot shade so above and below the line. No, none of the line was past your region. I remember somebody shaded here in the class. And so in that case, this line is passing through the region, which makes it incorrect because no line must pass your region, because it means then you'd have shaded above and below the line. You must not shade above and below and below. It's above or below. But the point is, the region is usually bounded by your 4 lines. The region is usually bounded by your 4 lines. In other words, the 4 lines form the boundary for the region that you want. And that region is in green. All right, everybody good so far? I'm taking my time with this one. I'm taking my time with this one.
Yes, sir.
Because I want us to understand it. All right. I mean, we'll start a little bit later. We're gonna finish after 1:30. All right. All right. So let's continue. So the next part of the question was first to mark the vertices, eh? Name the vertices or write down the coordinates. So we usually name them so we can reference them. And you name them with capital letters. You name them with capital letters. So I'm going to name this one, that vertex, this vertex, this vertex, and that vertex. So if you have 4 lines bound in the region, you must have 4 vertices. Let's name this one A. I'm going to name this one B. I'm going to name this one C. I'm going to name this one D. Now, you don't have to name them A, B, C, and D. You don't have to name them in the same order. It doesn't matter. Everybody's labeling will be different. Most time we just use A, B, C, and D. And you could have named this one B instead, this one C, this one D. You can name them anyone, anything. Just make sure that what you write corresponds with your diagram. All right. So if I'm going to write down those vertices now, I'm going to write down those. In fact, let me name them differently, just to be deliberate. Let me label them differently just to be deliberate this time. So I'm going to label this one A today. I'm going to label this one B. I'm going to label this one C. I'm going to label this one D. Just to indicate to you that there's no, most persons did the A, B, C, D in class. So I'm being deliberate in labeling this way to show you that it doesn't have to be in any particular way, in a particular order, but your solution must correspond to what you label. So in this example now that I've labeled, right, the A is right here, which is the point 10, 10. So that part of the question, which was B2, I think, B2 said we were to, put down the vertices, right? Where is it? B2 or shade the region. It was B3, B3. So it's actually B3. Put down the coordinates. All right, so I'm answering B3 now, which are the coordinates. I'm labeling them A, and A will be 10, 10 right here. B right here. B will be 5, and this is 12.5. Halfway between 10 and 15 is 12.5. It's like the midpoint, guys. So you're averaging then 10 plus 15 over 2, which is 25 over 2, which is 12.5. That is right here. All right. Like the midpoint between 10 and 15. So, you can still apply your midpoint formula thing to do it. But right here is actually 12.5. So this point is 5, 12.5. And that I'm calling that point B this time. 5, 12.5. And then I'm going to go for C. See, in this diagram is 5, 5. I'm going to go for D. D in this diagram now is 15, 5. 15 is the X value. 5 is the Y value. 15, 5. So D is 15, 5. So those are the vertices on this diagram. All right. I just chose to label them that way. It doesn't matter specifically what letter you give to a point. Just make sure what you give it is consistent with the diagram. All right. So those are my vertices. So that would end the part B. The graph, the shaded region, and the vertices. All right. Now down here now, they're giving us some information about profit. And oftentimes linear programming really is about finding the points or in terms of the phones and the radios. What's the right number of phones and radios that you must sell under the constraints and the limitations, under the condition that they described above, to maximize your profit. Because what this graph means, guys, it means that you can decide to sell or stock any combination of phones and radios that is inside this region or on any of these lines, any combination of phones and radios that can be stocked inside the region. All right. So I can decide to stock. And another thing I want to indicate, and we can talk about this point a little bit, right? Talk about this point a little bit where the coordinates are 5, 12.5. That point. But this point is really saying 5 phones and 12.5 radios. So I have a challenge with this 12.5 radios. You're not going to stock 12.5 radios. All right? You're not going to stock 12.5 radios. So this is an example of when that vertex really cannot be used. You really cannot use that vertex in a real sense, because you're not going to stock 12.5 radios, 12.5 radios. This is 5 phones, but that vertex is saying 12.5 radios or 12.5 radios. So really and truly, you cannot use that vertex. For the purpose of our calculations, we can use it to see what we'll get with the numbers. But in realistically, in real life, you could not use that vertex. And when a vertex cannot be used, it means that you would have to come along the side. That's along the side, which means that you'd have to come down here. The first point down this way, you'd have to go. And so the point that you really can use would be 512. 512. Because this, you cannot have 12.5 radios. So instead of trying to stock 5 and 12.5, you really can only stock 512. You can't go 513. You can't run up 12.5 to 13. Why can't I run up 12.5 to 13? Right? Instead of going 5. Because 513, if you look at it, will be taking you this way. That will be taking you outside the region if you were to go this way and go to 513 up here. That will take you outside the region. But understand what I'm saying? So whereas you can use 512, you could not use 513. You could not use 513. You can't use 512.5 because 12.5 radios don't exist. So you have to use 512 because 512 takes you back within the region, takes you back within this bounded region that you can use. Students, understand what I'm saying there? Understand what I'm trying to explain there? With this 12.5?
Yes, sir.
Yes, sir.
Huh? Sure. It's very important that you understand this, guys. Because I said to you, there are times when a vertex cannot be used. I've said it to you. There are times when a vertex cannot be used, and this is one example. Another time when a vertex cannot be used is when there's a broken line on that vertex. Remember, you cannot use any point that is on a broken line. So if you had a one where you had to draw a broken line because you only had a greater than or a less than sign, you draw a broken line, you cannot use any point that is on a broken line. And when you cannot use a vertex, you go to the first point along the side that is bound in the region. And the side has to be on a solid side, a solid line side that you can use. So technically, we really cannot use this point. 12.5. We really can only use this point, 12.5. But I allowed students in the class to calculate with the 12.5 because it still did not affect the maximum that we're trying to calculate. All right, but I just wanted to take this opportunity to show you that. All right, that there are times when a vertex cannot be used. All right, let me see if I can clear this up a little bit. All right, let's write about the B. So this is our B, and this is our vertex right here. All right, so that is that. So let's continue though. We'll erase some of the shaded region and erase some of the lines accidentally. All right, let's go again. Let's try it. It doesn't really matter. I can leave it at that. All right, so let's go now. So next part now start to talk about profit, right? Taking my time with this question because if you can fully understand this one, then you can do any other one because you know the concept and what you do with these linear inequalities in linear programming basically the same regardless of the information what they give you. So you need to fully understand the first one that you do, and then by extension you'll understand the others when you practice. All right, so the next one says the owner of a shop sells now the devices, the radios and the phones, to make a profit of $80 on each phone. So let's write it down here now. So remember, let's write it down here. So for part C, you had X phones and you had Y radios. I'm just writing this back so I don't have to scroll back up. And in terms of profit now, in terms of profit, he's making $80 on each phone, on one phone. So if he sells 2 phones, that's $80 times 2 profit. If he sells 3 phones, that's $80 times 3 profit. So he's making a profit of $80 each on the phones, each on each one, and on one, $80 per phone. And he's making a profit of $100 on each radio. That's $100 profit he's making on each radio. So he's making profit on the phones, plus he's making profit on the radios. All right, read them again. Radios. So the question says, express the total profit in terms of X and Y. The total profit, see? Total profit. That's on the radios and on the phones. So I'm going to write an expression that says total profit. I'm going to call that total profit P. I'm going to put the dollar sign in front of it. Total profit is P dollars. Now, what is P equal to? P is going to be equal to the profit that is making on the phones first, plus the profit that is making on the radios. So if he's selling each phone for a profit of $80, and the number of phones he's selling is X, then it's 80 times X. If it was 2 phones, it would be 80 times 2. If it was 3 phones, it would be 80 times 3. If it was 4 phones, it would be 80 times 4. It is X phones. X is the number of phones. So the profit on the phones is 80 times X. So I'm going to write that as 80X. I don't have to put the dollar sign because I already defined it as P dollar. So I don't have to put the dollar sign. So the P is just a value now. Plus the profit on the radios. And it's $100 on each radio. So if there are 2 radios, it will be 100 times 2. If there are 3 radios, it will be 100 times 3. If there's 4 radios, it will be 100 times 4 profit on the radios. But this is Y radios, and so it's 100 times X times Y. Sorry, 100 times Y is a profit that is making on the Y radios. Remember, you don't know X and you don't know Y now. You don't know X and you don't know Y because you can use any combination. Let me show you. You can use any combination of X and Y inside this region, the shaded region. Any combination of X and Y inside that region, any combination of X and Y on this and those lines. So you don't know which combination it's going to use. So you're getting a general formula for the profit that you will make for any combination he uses that is inside this region. He can use any combination inside that region. So to complete this now, we're going to put in the 100 times y. The profit is making on the radius. That's 100 y. So this is the formula for his total profit. So for any point inside here, so if he decides to sell, for example, a point here, which maybe looks like, say 9 phones and maybe say 7 radios, right here. He can do that because that falls inside the region. So it will be 80 times 9 plus 100 times 7, because the point that is in the region is 97. And this will be the profit that he makes if he decides to sell this number of radios and phones, or phones and radios. All right, any combination. So that is the formula, an expression for his profit, the profit that he's going to make on selling X phones and Y radios over here. That is a profit. That is the formula. All right. Then now the question wants us to determine the maximum. See, calculate the maximum profit. And these questions I always like to ask you to calculate some maximum or minimum something. So part 2. So to calculate the maximum profit, we know maximum or minimum of anything in these questions, they happen at a vertex, one of the vertices. And it's a maximum that we want. So you really want to go to the vertices, right? And you have to be smart about it as well. So this vertex, clearly you cannot maximize the profit there because you only have 5 phones and 5 radios there. That's the smallest number of phones and radios that you sell as a combination at that vertex. But the thing is, his maximum is going to be either here, here, or here. Why is one of those 3? Because this point has an advantage in the y value over these 2 points. This point has an advantage in the x value over this and in the y value over this. And then this point has an advantage in the x value over these 2. So therefore, you're not going to be able to look and know which one of these 3 points will maximize your profit. And so the safe thing to do is to test what the profit is if you operate there, test what the profit is if you operate there, and test what the profit is if you operate there. So you test all 3 points. Remember that this point, is really 512.5, which really and truly can't be 12.5, has to be 512. But if we work with the 12.5 and you get another point that is giving you more than this point, then you know that, okay, you're still good. All right, because if you do the 512, which is the real value that you really can use for that vertex, 512, then, you don't maximize the profit there, then, you're still going to get the other point that gives you more than if you use a 512.5 is a better point anyway. So we're going to work with the 512.5, even though that we know that the 512.5 realistically cannot work. Okay, it cannot have 12.5 radius. So I want to test for which point is the maximum profit. You have to test for it. You cannot look and know. You always have to test at least 2 points. You want to work with maximum in these questions. So I want to test for maximum profit. So we're going to test the points. We're going to test these 3 points, as we said. Right? We're going to test A, B, and D. Don't, in a sense, waste time and test C. C clearly not going to give it a maximum profit. All right, so let's write them down. So we're testing point A first. And at the point A, they have in 10 and 10. We wrote them down already up here. See there, 10 and 10. 10 phones and 10 radios. So A is a point 10, 10. So you're substituting the 10 in the profit formula here to work out what the profit is going to be. So I'm going to write it here now that the profit at A would be 80 times 10 plus 100 times 10. And that will be 1,800, because this is 1,000, that is 800. So 1,800. I want to work in dollars, but I don't need to put the dollar sign just yet. If we're operating at B, I'm going to use the 12.5, even though 12.5 really can't work. But if I get another point that is giving me more, even when I use 12.5, then I will know that that point is still not a valid point for the maximum. B is a 0.5, 12.5. So I'm saying the profit at B would be 80 times this X value of 5 plus 100 times this value of 12.5. And this one works out to what? No, that is what? Let me calculate it quick. Anybody remember that what that one was? That a 17 or 1650. What was it? Remember? Let's work it out. 80 times 5.
Sir, B is 1,700.
1,700. No. Remember, guys, I'm using a different B in this diagram. So to see, I'm using a different B. So this one is 1,650 by my calculation. 80 times 5 plus 12.5 times 1. So this is 1,650. They're not the same B that some people use. If you look what my point is, this is my B now. That's my B. Most persons use this as B in the class, but I deliberately change it for persons to understand that you can give any point, any letter you want, that will work with what is in front of you. Understand what I'm saying there?
Yes, sir.
And then my D now, I'm using the point D now down here. D now is what some persons use as their B. That is 15.5 down here. And so the profit at D in this example would be 80 times 15 plus 100 times 5. And this is the one that is now 1,700. But good at that?
Yes, sir.
All right. So clearly then, the highest value of the three is this one. So therefore, you want to be operating at point A. When you operate at point A, you will maximize the profit in this venture. And so we can write a conclusion and say the maximum profit that is possible under these conditions, maximum profit is $1,800, 1,800. Now notice I put the dollar sign now because I'm writing a statement. I can also state what I must sell to get it. I can say when I get $1,800, when 10 phones and 10 radios are sold. Right here, 10 phones and 10 radios. And that's my answer right there. But good at that? But okay?
Yes, sir.
Yes, sir.
Any question? Any question on it? But all right, you can move on.
Yes, sir.
All right, so let's continue. We're gonna do a number of questions. I want us to do at least 2 more linear programming, and I want us to do a few linear inequalities with the number line and those things, and see sometimes how they do a combination setup for these questions. All right, so I'm gonna bring up a couple past papers now. I'm gonna work them. All right, to see how they start changing some of the questions and they're setting them in a way that really tests your understanding of it. Okay, so let us see. The more you practice, guys, the easier these things will get. All right, so let's look at 2023, which was this year. Let's look at 2023, which was this year exam. 2023. This is the very last exam that CXC set. The paper that was leaked and was not marked, did not form part of the grade or the grading for the CXC exam. CXC decided not to use it because it was leaked. But you know what? It's still an exam paper for us to practice from. So it intended to be the exam paper. So questions on this paper are still valid. So here's a simple linear inequality to do. All right, this one right here. Only 2 marks for it, but can't just say only 2 marks because most questions is 2 marks or less. Most questions. So what are those 2 marks? We need to get it right. So that's an inequality. Remember, solving that is same as solving 12 minus 4m equals 5 minus 8m. Same steps as solving those. We're trying to make m the subject. All right. So let's say we're going to group them on this side. I'm going to take this negative am and bring it over this side. I'm going to take this 12 and take it over to that side. That's the transpose that we're going to do. Remember, we only reverse this sign if we multiply or divide with a negative number. All right, so I think this one is pretty straightforward. So I want to take this negative 8m, take it on the right side, becomes a positive 8m, and this negative 4m remains where it is. So it's going to become 8m minus 4m. This sign stays less than. This 5 is over there already, and this 12 goes over and becomes a negative 12. The same thing we'll do if it was an equation. And this 8m minus 4m is 4m. Less than or equal to 5 minus 12 is negative 7. Then to make m the subject, I'll divide by a positive 4. So because I'm dividing with a positive number now, the sign will stay as it is. So I'm going to get m less than or equal to negative 7 over 4. That's my answer. But okay with that? I know I have m as a subject. But good?
Yes, sir.
Yes, sir.
All right, but good. All right. Let's just do it one more time. If we group the m on this side, on the right side instead. Let's do it again if we group them on the right side and see what the difference would be. In that case, you have to divide with a negative, but the result must be the same, which is the harder way, right? No, not the harder way, the longer way. All right. So let's say I'm grouping the m on the right side of the inequality. So I'm going to take this negative 4 and bring it on this side. I'm going to take this 5 and take it onto that side. All right, that's going to be the transpose if I'm doing it that way. So firstly, this 12 remains as it is. This 5 goes over here and becomes a negative 5. So 12 minus 5. The sign remains less than or equal to, because I did not multiply or divide. This negative 8m is there already. Negative 8m did not move. This minus 4m comes over and becomes a positive 4m. It's a plus 4m. So we have that. Then this 12 minus 5 is 7, less than or equal to. This negative 8m and plus 8m becomes a negative 4m, sorry, negative 4m. You have to divide by this negative 4 this time. So now I'm dividing with a negative 4. So let's go. I have to divide by negative 4. But because I'm dividing with a negative number, I have to reverse the less than or equal to sign for it to remain true. So this will become negative 7 over 4, or 7 over negative 4, same thing. 7 over negative 4, which is the same value as this, same value. The sign is reversed to greater than or equal to, and this side will become an m. Now, if I read it this way, from left to right, it is saying m is less than. If I read it that way, if I read it this way, from left to right, it's saying m is less than or equal to this over here. Read it from left to right. Reading it this way, the same as saying that the m is less than or equal to 7 over negative 4. But the same answer this is now, because 7 over negative 4 and negative 7 over 4 is the same. It's the same. Same value. If we were to work it as a decimal, it's going to be the same value. So that's how we get this answer, which is the same as this, really. But go to that. But okay?
Yes, sir.
All right. So we have to remember, guys, we multiply or divide with a negative number, you have to reverse the inequality sign. This is if I read this inequality from right to left. This is what I'm going to get. All right, that finishes that one. I think that was the only question on that paper. Let's do this. Let's just do a series of the linear inequalities, and then we're going to come back and do the linear programming. All right, let's just do a series of the inequalities. So let's go, and there's another one on 2019, which was set up a little bit differently. 2019 is right here. 2019 4B. And let's look at this one now. 2019 4B. Where are we? Let's look at this one right here now. There you go, look at this one. We have not done any of these in the class. We did not do any in the class. And see, that's why I have to do past papers. So this is like you have two inequalities in one another. It's like you have one here. I have another one here. Like you have two in one. Right? But then now we can work with this and still transpose and leave x in the middle. When you leave x in the middle, you have solved it. You want to leave x in the middle. This side is less than, this side is less than or equal to. You want to transpose away the 5 and transpose away the 3 and leave x alone in the middle. When you have x alone in the middle, you have solved it. So let's go step by step now. The first thing we're going to do is we're going to, let me write this out first. So you have to realize that this really is two inequalities in one. This side, which is -7 less than 3x plus 5. Sorry. And it's also this side, which is 3x plus 5 less than or equal to 7. So like two inequalities in one. So I can decide to solve it separately, that one and this one. But as I said, it is possible to solve it all in one. Just transpose everything away from the x inside here and leave x in the middle. All right? So the first thing we'll have to do is move this 5. So to move the 5, we subtract 5. I'm going to subtract 5 from all sides. So this inequality has 3 sides. 1, 2, 3. It has a left side, it has a middle, and it has a right side. We're going to subtract 5 from all sides. Subtract 5. So because I'm just subtracting 5, there's no need to reverse the inequality sign. When I subtract 5 from this side, I'm going to get -12. Tell me if you see it now, guys. -7 and -5 is -12. I'm just going to write it. -12. Inside, I'm left with a 3x. If I subtract this 5, I'm left with 3x. Less than or equal to. When I subtract 5 from this side, I'm going to get 2. But I say that, if I subtract 5 from all sides, but I go do that.
Yes, sir.
Then now to leave x inside here, I have to divide all sides by 3. So I'm going to divide in here by 3, divide here by 3, and divide here by 3. I'm going to show it like that, because I like when the mathematics is clean. And so I'm going to divide all sides by a +3. So because I'm dividing with a positive number, these signs are not reversed. If I was divided with a negative number, I would have to reverse them, both of them, if it was a negative number I'm dividing by. But this time I'm dividing with a +3. No need to reverse the signs. Less than or equal to signs. Less than and less than or equal to signs. I don't have to reverse them. If I was dividing with a negative number, I would have to reverse both of them. So when I divide by -3, divide by +3, this side becomes -4. This divided by 3 is -4. Less than, I have x alone inside here now. Less than or equal to, this becomes 2/3. So this is my solution. When I get x alone in the middle, that's my solution. This means that x is between -4 not including -4, and 2/3 including the 2/3 because the equal is on that side. Understand that, guys?
Yes, sir.
So that is my answer right there. That's after the past paper. So we can see different ways in which they set the same things. Different ways. All right, let's continue. I think I want a number line for this one. See here? It says represent your solution on the number line. So basically I want to represent this inequality on this number line down here. And all they gave us was this 0. All right. So we need to put in such that we have a -4 and a 2/3. 2/3. So what I'm going to do, I'm going to go and just put on some number, starting from 0, I'm going to put some values to the left and values to the right. All right. So I'm going to put -1 here. I need to be able to fit -4 on it, right? -1, -2, -3. Let's put -4 right here. And then now, based on that, I'm going to put 1 right here and 2 right there. All right. So my two critical values, my x is between -4 and 2/3. It's like this means between, because that -4 is the lowest value. 2/3 is the largest value, but you're not including -4 because the equal is not there. So I'm going to put a circle on the -4 over here. But I'm leaving it unshaded because there's no equal on that side. And then I'm going to put a 2/3 on the right side. 2/3. So if this is 1, if I break this in 3 equal parts, let me put it in red. Like I break this in 3 equal parts by putting in 2 lines. So like this is my 2/3 right here. This mark represents my 2/3. I don't reach 1. 2/3 is less than 1. 2 or 3 parts. So like I split it in 3 parts. See? 1, 2, 3. I put in 2 lines there. And then this is more 2/3 of the way. So I'm going to put my circle on this line, the 2/3 line, right there. But because the equal is on this side of the inequality now, I'm going to shade this one, shade it. Shade it. And then now, because I want between them, I'm going to join these now. And like x is somewhere between them. See? The x in the middle is greater than the -4 out here. But it is less than or equal to this one. So it's greater than the -4. And at the same time, less than or equal to 2/3. X in the middle. So I can put an arrow this way, meaning that my values are less on that side, and put the arrow this way, means that the x is now greater than this. So it's like I want the region in between them, above this one, but less than this one. That's my number line. But okay with that?
Yes, sir.
So a question like this, you go and you do it over again, you practice it, because we have not done any like this in class so far. So we'll start with the basics in class, but then we'll practice. So we'll do the basic ones multiple times first, and then when we are comfortable with the most basic ones, then we'll practice and we'll move up the scale, move up the ladder. It is progress before perfection. All right, so that is it. So we have not done anything magical on the question, but it's just set out a little bit differently. All right, let's look at 2018. There's another one at 2018. All right, let's look at it. Another linear inequality at 2018. Let's set them quite frequently. Let's set them quite frequently. Let's do a third one and see. 2018. And I did not get a chance to sort of search for the questions properly because I'm not traveling. But and I really woke up late this morning, just a few minutes before the time for class. So I did not get to go through and pick out the questions for today. But I think we have enough to finish the class today to get a good representation. So look at this one now. This is another example here. All right. So look at this one now. So they're telling us to solve this first. In other words, we're trying to make x a subject. So I'm gonna move this one over here first. Remember, it's a linear simple inequality. You only reverse this inequality sign if you have to multiply or divide with a negative number. All right. So I'm gonna move this one over here first. So let's say I'm gonna add 1. This is what we do. You don't have to, but you can also do it. So we're adding 1 to both sides. Same as saying take the 1 over here and add it. So we're gonna get 3x less than 12 if I add 1 to this. And then now to get rid of this 3, we're gonna divide by 3. The similar question to what we just did, but set out a different way. Divide by 3. Because we have to divide by 3, we're not going to reverse the sign. I'm not going to write it this time. Because we divide with a positive number, there's no need to reverse the sign. The sign stays as it is, less than. And so we divide both sides by 3. This becomes x. And this becomes 4. So x is less than 4 as a solution for that part. And then now we have this part to solve. If you notice, this expression is the same as this expression. So really and truly, if you were to combine these two, right, then what you really have is a situation where you have the 3x minus 1 in the middle, less than 11. You must recognize what you have. And this one now is saying that the same expression is greater than or equal to 2. Greater than or equal to 2. So it's almost like they give you this to solve in a guy, but they give it to you in 2 parts. That's what it is, you know. That's what you have to recognize. That's what this is really. So they're giving us this to solve in 2 parts. Right? It's almost like they're helping us. They could have just given us that to solve in 1, as we did in the previous question. But this is to show you how they can basically set the same question in different ways from time to time. All right. So, but then again, if you're solving this now by itself, again, want to leave the x as a subject, then we would add 1 again to get moved from here. So we're going to add 1. So add 1 to this side and to eliminate that. Same as saying take this -1 and make it positive. And so we would get 3x greater than or equal to 3. And then move this 3 now, we're going to divide by 3. So we will divide by 3. Again, same 2 things that we did at the top. Leave the x alone by itself. And so we would get this side divided by 3 now is a 1 less than or equal to x. So 1 is less than or equal to x. Well, this is really the same as x greater than or equal to 1. Because if you read it from the right to left, this is what it becomes. So if we were presenting this as a solution, what we have really done a while ago is solve that. All right, I want to see that now. They give us a combined. They gave us a combined in this part of the question now here. Is a combination of those of that. They put it for us now in that answer. But it would be good for us to recognize from the get-go that we're really solving this at interval. And so they put it for us together there now in this part of the question, the combined first now. And they're saying now, represent the solution for this. So to represent the solution for this, what happened to some students is that they did not recognize that this really was a combination of these 2 that they gave us to do, which can be written like that, which is what we have here. All right, and so you really want to represent a combined solution of this and this. What is that really? If you combine this one and this one, put x in the middle, what would happen is that this solution, write it here, would really become x in the middle is this side first, greater than or equal to the 1, and then this side less than 4. That's what you would get if you were to solve this thing in the red box the same way. If you have this to solve the same way, which really is this down here, you would add 1 to all sides first. And your second step, I'll write it in here for you. Let me remove this and write it for you. If you add 1 to all sides first, if you add 1 first, as we did over here, where we added 1 first in both instances, we would end up getting the 3x less than 12 greater than or equal to 3. And then our next step would be to divide by 3 as we did each time in these two. Divide by 3. And so if we divide 2 by 3, this in the middle will become x. You see what? It will become this result, right? If we divide by 3, it will become this result. Put it in red. Become this result. X in the middle. Divide this by 3, we'll get the 1. And divide this 12 by 3, we'll get the 4. So we'll divide by the 3, we'll get this as a result that we have there. And so now the line that we're drawing, the number line that we're drawing really is for this solution. Right? We really want to represent this on this number line. And that is the solution for this inequality right there. So x is between 1 and 4, including the 1, but not including the 4. So you put a circle on the 1 right here. And you shade it because the equal is on that side. You shade it. You put a circle on the 4, which is here. But you leave it unshaded because there is no equal on the 4. And you want x to be between them. So you put the arrow, put a line straight across because you want x in the middle. Erase this now. You want x in the middle to be greater than or equal to the 1 over here, but less than the 4 over here. And I can put the arrow pointing this way to show that my x is less than 4. Put the arrow pointing this way to show that my x is greater than 1. That is a number line right there like that. But good at that. But okay?
Yes, sir.
Yes, sir.
All right. So we have to practice these things, guys, right? We have to practice. We have to practice. So the different ways to set the same things. All right. So let's look at a couple of linear programming now. There is one on 2022. So let's go back and find that 2022 paper. There's one on 2022. Where are you? 2022. 2022. Where are you? 2022. All right, so 2022, there's a nice one on 2022. All right, which is right here. All right, so this is similar to the ones we've been doing, right? To give us information of right inequalities. All right. It says a rental company has X cars and Y minivans. So X is the number of cars, Y is the number of minivans. And we have done vans and cars question in the class, so should not be distant from you in thought, right? And when you're doing these questions, as I said, think of it in a realistic way. Don't just look at the numbers and the maths and what they're saying. Just imagine you have a company, there's a company out there that has a number of cars and it has a number of minivans. Right? And there are conditions under which they can have the cars and the minivans. They don't know X and they don't know Y. But there are conditions under which they can have certain number of cars and certain number of minivans. And I'm going to tell you those conditions. Those conditions are called limitations and constraints, and they are represented by inequalities, linear inequalities. All right. They said the company has at least 8 vehicles altogether. So the word vehicles is thing to mean the sum of the cars and the minivans. There's an inequality for this, you know. It has at least 8. At least 8 means 8 or more. They are telling us down here to write 3 inequalities. I'm going to start with that first statement. And now I see it, I'm going to write it all together. The number of cars, which is X, plus the number of minivans, which is Y, that's the total number of vehicles, must be at least 8, must be 8 or more, greater than or equal to 8. That's it. That's the inequality for that one that I've underlined. But understand that? That's the first inequality. But I'm good at that?
Yes, sir.
So a lot of people see the word least and put the less than sign, but put it in real context. I always say, think of money. If you must have at least $8 to buy something, everybody understand that at least $8 means $8 or more. That's what at least $8 to buy something. If you say how much for that pencil, how much for that sweetie, and you don't know for sure, but somebody say it is at least $8. It means that you cannot go there with less than $8. You have to go there with $8 or more. So at least 8 means 8 or more. At least 8. 8 is the minimum. So the total number of vehicles, which is represented by X plus Y. X is the number of cars. Y is the number of minivans. The number of cars plus the number of minivans must be at least 8. 8 or more. So this is the inequality for that condition. All right. Then what happens is that they lump up all the conditions in this one statement, you know. They lump them all up in that statement, and then they want to write 3 inequalities. So if we read and extract. Next part says the number of minivans. What's the number of minivans? Number of minivans is Y. So this is talking about Y. Is less than or equal to the number of cars. So this is an example to give you the inequality straight. The number of minivans, the number of minivans is Y. Less than or equal to the number of cars. The number of cars is X. So that's inequality right there now. Number of minivans is Y, less than or equal to the number of cars, which is X straight. So that's a straightforward inequality they gave us right there. That's the second one. And then now they give us yet a third one in the statement. It says the number of cars, which is X, number of cars, which is X, is no more than 9. No more than 9. 9 is a maximum. 9 is a maximum. No more. Can't be more. No more means less than or equal to. Can be equal to 9 or less, but can't be more. So the number of cars, which is X cars, must be no more. No more. Can't be more. Means it can be less or equal to 9. So the 9 here. So the third inequality is that X has to be less than or equal to 9. So those are 3 inequalities right here. But understand that it must make sense to you guys. It is English language to mathematics, but it must make sense. But I go to that?
Yes, sir.
All right. And here they are telling us to write these 3. Write down the 3 inequalities in terms of X and Y, other than these 2, because these 2 are understood. Because if you're stuck in cars and vans, then the X has to be greater or equal to 0. The number of cars must be greater or equal to 0, and the number of vans must be greater or equal to 0 as well. So that's why they say other than those 2. But these 2 are given, these 2 are understood to represent the information. And these are the 3. I will plug them out one at a time and do those 3 inequalities. What else they want us to do? Or they want us to write them here. It don't matter, write them there. It says a car, remember there are X cars, right? How many cars are there? X cars. So X cars, remember there are X cars. One car can carry 4 persons. One car can carry 4 persons, right? One car can carry 4 persons. And a minivan, remember the Y is the number of minivan, but each minivan can carry 6 persons. It said that there are at most 60 persons to be taken on a tour. At most, the most persons can take on a tour is 60. They say show that 2x plus 3y is less than or equal to 30. So in other words, they want us to develop an inequality and reduce it to this based on information. All right. So remember now, there are X cars and each car is carrying 4 persons. So if there are 2 cars, it will be 4 times 2. If it were 3 cars, it will be 4 times 3 persons. If it was 4 cars, it will be 4 times 4. 4 persons times in 4 cars. If it was 5 cars, it will be 4 times 5. But there are X cars. There are X cars. And each car is carrying 4 persons. So the total number of persons in the cars is 4 times X. 4X. The total number of persons in the cars. 4X is the total number of persons in the cars. Plus the persons in the minivan. The minivans. Now, each minivan, they say, is carrying 6 persons. Think of it. Vans carry more persons than cars. And they're going to put 6 persons in each van. If there were 2 vans, that would be 6 times 2. If there were 3 vans, that would be 6 times 3 persons. 6 times 3 is 18 persons. If there were 4 vans, that would be 6 persons times 4 vans. 6 times 4 is 24 persons. But there are Y vans. Remember, I don't know how many vans there are, but they're putting 6 persons in each van. There are Y vans. Let me just write vans. Instead of saying minivan, let me just say Y vans. And I put in 6 persons in each. So it becomes 6 times Y. The total number of persons in the vans is 6 times Y. So the total number of persons in the vans is 6Y. This represents the total number of persons they are carrying. These number of persons in the cars plus these number of persons in the vans. What they're saying, at most, there must be 60 persons taken on the tour. The tour is a tour of persons going, some in cars, some in vans. But the total number of persons on the tour is a maximum of 60. So the total number of persons can't pass 60. So this represents the total number of persons being taken on the tour. It has to be less than or equal to the maximum number of persons of 60. But understand that? So this is the inequality.
Yes, sir.
And then to get this result, all you see, you realize that it is divided by 2. Because if I get this, you should always divide it down to the simplest terms. So all you're doing now is dividing this through by 2. Because we divide with a positive number, there's no need to reverse the sign, right? So when you divide this by 2, you get the 2x. When you divide this by the 2, you get plus 3y. You divide this by 2, you get the 30. But the maximum number of persons can take on the tour is 60. But that inequality simplifies down to that because they are taking 4 persons in each car, 6 persons in each van. And this is the maximum number of persons they can take. But the inequality in a simplified form becomes this. So far, so good? But good so far before we move on?
Yes, sir.
Just think of it realistically. Don't think of it in an abstract way. Think of it realistically. So we have 4 inequalities that they gave us overall. So you expect to draw 4 lines. And you expect to get a quadrilateral with 4 vertices. All right, so you're thinking ahead what you're gonna get. All right. Next thing I want us to do, let me shift this over because I want to write the information because to draw the graphs, we're going to write the information. I'm going to shift this over a little bit. So this has been shown, right? I'm putting it here so I can write the information to the right, or need to put. So see here now, it says on the grid. So in this case now, they give you the graph. They draw the graph for you, as I did in the class, right? It says on the grid below, plot the 4 lines. Plot the 4 lines associated. That's a term that I've been using in the class. The lines that are associated with inequalities. After you draw the lines that are associated with inequalities, then now you're going to shade the region and label the region that satisfies all 4 inequalities. They want us to label it R. So they don't want us to shade it this time. They want us to label it R. Most times they want us to shade it. This time they want us to label that region with an R. Follow the instructions, guys. Follow the instruction. But there's a shade. There's a shade and label the region R. Okay, they want us to do both. Shade and label the region that satisfies all 4 inequalities R. So they want us to do both, shade and label. All right. So let's the chain of thought. I can do these inequalities straight enough, but what is the chain of thought to doing it? So what I'm going to put on the screen now, you don't have to write on the paper. You're not getting any additional marks for writing these things on the paper. You're getting the marks for what they ask you to do. All right? So don't think by putting what you're going to do and then doing the wrong thing. If you do the wrong thing, you're going to lose the marks, even if you write what you're going to do. We want to put this one on a graph. This one means above. I'm going to write it beside it, above. What it means, what we're going to do. We want to go above the line. The y is positive, so greater than means above. Going to be a solid line. In fact, they're all solid lines because all of them have the equal in them, equal in all of them. So all solid lines, all solid lines. So I'm still going to write the word solid. mean that we want an unbroken line, a solid line. And the line associated with this one is x plus y equals 12. X plus y equals 8, sorry. And this one passes through 0, 8, and 8, 0. I told is one of the popular lines, the x plus y line. X plus y line. And then this one now, the less than means below, because y by is positive, so one below this line. This is a chain of thought. The line is solid. We're going to draw a solid line for this one. And the line is y equals x. The line associated with this one is y equals x. Replace that inequality sign with that equal to get the line. And this is the line that passes through 0, 0 and passes through points where the x and the y value is the same. Another easy line. So for example, to pass to a point like 4, 4. 4, 4. Because the magnitude of the question is like 8. That's sort of number, and 9. So I'm not going to put no 30 and 40 this time. It's 4, 4. If you even look at the graph, the straight graph goes up to 11. So it could maybe go 8, 8. So for example, 8, 8 will be right here. And it pass through 0, 0. So your line y equals x is going to go like that. All right. But let's finish up the consideration. These things in purple are what you're thinking, what you're going to do. Then this one now, the less than means below, and it is below, going below this line. But it's a vertical line, and below a vertical line is the left of it. The line is solid again. And the line associated with this inequality is x equals 9. And x equals 9, remember your y-axis is a line x equals 0. So vertical lines like your y-axis will be vertical like the y-axis will be x equal 9. So x equal 9 is a vertical line passing through 9. X equals a number line is a vertical line. So I'm going to put an arrow up here to remind me that it's a vertical line I'm drawing this time. And then for this one down here now, right? The y over here is positive, and so less than means below. So for this one, we're going below again. Below. And the equal is there, so we're going to be drawing a solid line. A solid line. The lines are part of inequality. So points on the line are valid. And to get 2 points on this line, guys, it's the same thing. To get 2 points on this line quickly, I'm going to just write them down like this side by side. One of them I'm going to give an x value of 0. The other one I'm going to give a y value of 0. So this one is going to be on the y-axis, and this one is going to be on the x-axis. So how do I know the y value to go here? If I put the 0 here for the x, it's like I wipe that out, 2 times 0 is 0. Then I'll be left with, then let me not do it on the inequality. Let me not do it on the inequality. Let me not do it on the equal. So the line is x is 2x plus, let me write the line here. The line that I'm drawing is 2x plus 3y equals 30. I don't want to do it on the inequality. Let's do it on the line. This is the line that I have to draw. This is the line associated with this inequality. So let's do it on this. So when I plug the x equals 0 here, like this is wiped out, 2 times 0 is 0. I'm left with 3y equals 30. If 3y equals 30, I divide by 3, you're going to get y equals 10. So you know that the y equals 10 when x is 0. So that is at 10. So this is the point on the y-axis, 0, 10. Then at the point where the y value is 0, like I put the 0 here for the y, and so this is wiped out. I am now left with 2x equals 30. If 2x is equal to 30, divided by the 2, you're going to get 15. X equals 15. So the point where y equals 0 on the x-axis, it means that the x value is 15. So this is a point on the y-axis. See, the y value is 10 on the y-axis. This is a point on the x-axis. See, the x value is 15. X value is 15. So it's 0, 10, and 15, 0. So those are what I'm going to put on the graph. Now you can put it on the paper here to help you. We're not going to get an additional mark for doing this, but that is not one of the questions that I asked. This is just to help you. All right, so let's go now. So the first one I'm going to do is the x plus y line passing through 8 up here. Let's put on the graph quickly. So it passes the y-axis at 8 up here. Draw it in blue. And crosses the x-axis at 8 down here. All right, I want above that line or below that line. Let's remind ourselves. We want above that line, above. All right, we want above the line x plus y equals 8. So I'm going to draw a straight line through here. And so it must also pass through 4, 4. So we need that line like this. Good enough. So let's say that my line, x plus y equals 8, label the line with the equal sign, x plus y equals 8. Put the arrow pointing up to remind me that I want above the line. So the region that I want is above this line. All right, but we're not going to shade it. We want to shade the wanted region, the region that satisfies all the inequality. The next line is y equals x, and I want below that one, y equals x, y equals x. The line that passes through 0, 0, 4, 4, 6, 6, 7, 7, 8, 8, so on, right? So y equals x passes through 0, 0, it passes through 4, 4 right here, and it passes through 8, 8 up here. So I want a straight line through those points. All right. So it's going to pass right down the middle of the graph if the graph has equal scale on the x and the y axis. And that's how I like to draw it sometimes. That's it. Label the line with the equal sign. Y equals x. And we want above, we want below this line, below. So put the arrow pointing down. Just below, below, right, below. All right. So the region that we want so far is somewhere over here because it has to be below this one and above this one. So we want somewhere over here, right? Let's put in the other lines now. The other one was x less than or equal to 9, right? So the solid line I want below the line x equals 9. So when I draw a line x equals 9, vertical line passing through 9. So 9 right here, so we need a vertical line passing through 9. So we really should have extended this one a little bit more. The y equals x line. Let's extend it a bit more up here. Y equals x, sorry, y equals x. This is y equals x. Now we're going below this line as we said. So put in x equals 9 now. So 9 here. And we're going this way. Vertical line passing through 9. So we're on this line now. This vertical line we're on. This vertical line right here. X equals 9. Draw it with your ruler, guys. Don't draw it free-handed like me. All right, I'm going to take it up here and label it with the equal sign all the way up there. This is x. This is x equals 9. I'm going below this line, means I'm going to the left of this line. So I want to the left of this, below this, and above this. So the reason that I want so far is inside this triangle, but I need to put in the last one first. The last line. There's another line, right? The last line is this one. Oh, above. Oh, sorry, wrong direction. Is this one. We say pass through 0, 10, and 15, 0. 0, 10 on the y-axis, 15, 0 on the x-axis. 0, 10. 0, 10 is up here on the y-axis. 0, 10. And 15, 0 is down here. So we need that line now. Wow. So you want to use the ruler again and draw that line. So what are some points that will pass? So let me figure out another point that will pass through. 6, 4. 6, 4. 6, 4. 6, 6, 4, 4, 6. All right, let me see. Let's see if I can draw it. It's a straight line down here. All right, straight line down here. All right, that line right there looks like that line. Let me see if this point is valid. 6, 6. So the line is just a test it. I'm not drawing with a ruler. If it's 6, 6, 6, 6. Let's see 6, 6 is on that line. It will be 2 times 6 plus 3 times 6. Well, 2 times 6 is 12. And 3 times 6 is 18. Right. So this one is add up to 30. So that is correct. So it pass through 6, 6 for real. Just check it because I'm not using a ruler. If you use a ruler, then you know for sure. But I don't have a ruler, so I'm just kind of double checking. All right. So that's it. That is it. This point right here looks like 9, 4. This is 9-4 to pass through that point as well. And I want below this line. So label the line with the equal sign. It was 2x plus 3y equals 30. All right, I want below this one, right? Below. And so the region I want is below this line, above this line, and below this line. All right, that's also going to be above right here. So you clearly see now that region I want is inside those, bounded by all those lines, right? So the region I want is here. Shade it properly. Yes, I must shade it, so I'm going to shade it. But I must mark it to the R as well. So I'm going to put the R inside here. Mark it to the R. And shade. Let's shade it in a different color after I mark it with the R. So let's mark it in green and shade it in green. So we want this color, we want this region inside here. And the x-axis also above this x-axis, which was for y greater than 0 down here. So down here says for y greater than 0, which is a natural inequality. So that's the region I'm getting, guys. That is it. But I go with that. But okay with that? That's that graph?
Yes, sir.
All right. So take it one step at a time. It all comes together nicely, right? All right. So I've drawn that graph. Next part now says, determine the two combinations for the minimum number of cars and vans that can be used to carry exactly 60 people. Remember, the inequality or the relationship that gave us exactly 60 people was 2x plus 2y. You want 2x plus 2y to be equal to 60. Because this was 2x plus 3y. Sorry, 2x plus 3y. Was the inequality relating to being less than or equal to 60? So if you want exactly 60 people, they have 2x plus 2y will have to be equal to 60. They want exactly 60 people. So the combination that's going to give you exactly 60 people is related to this line. Why keep writing 2y? 2x plus 3y. Is related to this line. It's not 2y we have, it's 2x, it's 4x plus, it was 4x plus 6y. Let me go start over. Right, so the inequality related to the 60 people was this. Let me start over. I'm trying to rush, right? See it right here, sir. I remember it. And we reduced it to the 30, right? The 2x plus 3. But it really started here. Because it told us to get the 60 people, it was based on the 4 persons being in a car and 6 persons being in a van. And so we ended up with this relationship. So for the exactly 60 people, if you want exactly 60 people, then your combination has to match the 4x plus 6y equals 60. That's it, you know. And this inequality, this condition, or this inequality reduced us to this, which was on this line. Because if you have this relationship for the exactly 60 people, then the line associated with it would reduce to 2x plus 3y equals 30. So the information for exactly 60 people is going to be found on this line. 2x plus 3y equals 30. So if we look at the graph now for that line, we're talking about this line. And to get the maximum combination, you go to the vertices. You're going to the vertices on this line. Because this line is where we're going to get the 60 people, you know. Remember, this equation came as a result of us having 4x plus 6y equals 60. So if you want exactly 60 people, you're going to have to go on that line. Put in 4 persons in a car and 6 persons in a van. And so the exact combination that you can get, because if you look at this graph, what does that mean, guys? That in between here, you don't have any solid number of x and y combination. So you have to come to this vertex and this vertex. The vertices is where you're going to go to get a maximum minimum of anything. This vertex is 9, 4. 9, 4. Let's label them for convenience, so we can reference them. 9, 4. And this vertex is 6, 6. 6, 6. This vertex, let's call it B, is 6, 6. Remember, I know we're talking about the number of cars and the number of vans, You can check it. If you have 9 cars and 4 vans, let's double check it and see if we get 60. It will be 9 cars by 4 persons plus 4 vans by 6 persons. If you check this, you're gonna get the 60. Because 9 fours is what? 36 plus 24. See, you get the 60 persons there if you operate here, so. And also the other point, if you operate at 6, 6, this place, 6, 6, 6 cars and 6 vans, it's gonna be 9 persons in a car by 6 cars, plus 4 persons in a van by 6 vans. 9, 6, 9, 6 is how much? What is 9, 6? 54. That's 54. How much is 9, 6? That's correct. No, not 9. It's 4 persons. My mistake. 4 persons. 4 persons in a car by 6 cars. Mistake. And 4 persons in a. Let me start over. So I'm doing 4 persons in a car. All right? 4 persons in a car. 4 persons in a car by 6 cars plus 6 persons in a van by 6 vans, right? So this is 624 plus this is 36. Let's double checking. And that now adds to 60, right? So you see that these two combinations will carry 60 persons. Students, understand that I know it's kind of being jumbled, but I don't want to know if you understand. You understand that? I want to explain it again. Anybody want to explain it again? You understand it?
Yes, sir.
Hello? Huh? Explain it
Explain
again?
that.
All right. So the question is asking us, right? What is the minimum? Question is saying, what is the minimum number of cars? What is the 2 combinations of the minimum number of cars and vans that can be used to carry exactly 60 persons? I see this, the highlighting certain things by putting in the 2 combinations in bold, mean that we need 2 points, 2 combinations of cars and vans. And they also put in capital letters here that they want to carry exactly 60 persons. So if we carry exactly 60 persons, that is an equal to situation. Now the information up here that they gave us that related to the 60 persons being carried was this, that 4 cars, each car carried 4 persons and each van carried 6 persons. And the equation that we started out with, or the inequality we started out with was this. But if you're gonna carry exactly 60 persons, it is still 4 persons in a car and 6 persons in a van to make the 60. So this combination would reduce again to the equation, this line. So this information is representing to point on this line. Points on this line. All right, it's just that we don't have this equation. We don't represent that condition on the line with this equation. We represent it with this equation. So the points that you want would be on this line right here. 2x plus 3y equals 30. That resulted from this relationship of 4 persons in a car and 6 persons in a van. So the points, 2 points that they want gonna be on this line. So if I look at the graph of that line, it is this line here, that line. And generally speaking, you get your maximum or minimum by going to the vertices of the region. So we want to be on this line, and we also want to be at the vertices. So these are the 2 vertices that are on that line. that will give us exactly 60 persons. Because remember, as we were saying, this equation of this line resulted from us having 4 persons in a car, and there were 4 X cars, so it's 4 times X, and 6 persons in a van, and there were Y vans. And that's how we can end up getting the 60 persons. So I'm saying to you that I'm saying it is these 2 points that they're talking about in the question, and I just wanted to prove it. Let's prove it down here again. If I look at the point A, let me take my time this time. 9,4. On this line, I'm going to show that this is equal to 60, because then it will be 4 persons in 9 cars plus 6 persons in 4 vans. This is 36. And this is 24. If you add it, you're going to get 60 persons. So show that this combination will carry exactly 60 persons. The other combination that will carry exactly 60 persons, let me write out the equal 60 or so. The other combination that will carry 60 persons is at this vertex on the same line, which is the point B, which is 6 cars and 6 vans. So again, it is 4 persons in each car, and there are 6 cars. So it's 4 times 6. Plus, it is 6 persons in each van, which is 6 now times 6. 6 persons in 6 vans this time. 6 persons times 6. Right? So this now is giving us 24, and this is giving us the 36. Again, they add to 60. So that proves that this combination as well will carry 60 persons. So these are the 2 combinations the question is talking about on the line at the vertices. The questions will always send it to the vertices. Once the question is about maximum or minimum, it's at the vertices, but because they want to carry exactly 60 persons, they have to come on this line, which is what represented the total of 60 persons, or the number of persons carried this line. So you come to the vertices. Those are the 2 vertices they're talking about. So the combination is 9,4 and 6,6. Understand it better now? So using A94 and B66. This is a combination of cars and vans. So this one is 9 cars and 4 vans. That combination will carry 60 persons. Or you can use this one, which is 6 cars and 6 vans, minivan, but I'm just right vans, will carry 60 persons exactly. Understand that now, guys? Better good at that?
Yes, sir.
All right, good.
Yes, sir.
Then the question says now, watch this now. It said the company charges $75 to rent a car. $75 to rent 1 car, you know. Remember, there are X cars, you know. There are X cars. So the total, the money from cars is going to be $75 times X, the money from cars. From the cars, from the rental of the X cars, it's going to be $75 times X. That's going to be the money from the rental of the cars. And they charge $90 for a van. Naturally, they're going to charge more to use a van. The van is larger, carries more persons. So the money from the vans, remember there are Y vans, you know. So the money from the vans is going to be 90 times Y. So that represents the total money collected from renting X cars and Y vans. All right. It says show that the minimum rental cost is $990. So what it is, remember, I know, it is to carry the same 60 persons, and the company charge these 2 parts represent the same part D, where they're talking about the 60 persons. So they want us to use these 2 points and say which one is the minimum to carry 60 persons. Understand? What I don't like about this question is that this part of the question is that they did not specify that they are talking about the same 60 persons referring to these 2 points. And so persons might go now on the question and start to work with these vertices. Right? But they're really talking about the carrying of the 60 persons, the exact 60 persons. We're talking about this store of 60 persons. So see, it says now that the company charges $75 for a car, $90 for a minivan. Show that the minimum rental cost, it specifies it for this store. This is the key phrase right here. for this tour. The tour that they're talking about in part D, not for any tour, for this tour of 60 persons, of exactly 60 persons. And you carry exactly 60 persons either using this point or that point to carry exactly 60 persons. So you want to know what the cost is for this point and what the cost is for this point. But first, I have to establish that the cost is this. So the cost for the tour, let's write it as cost. The cost for the tour is C dollars. Let's say C dollars. Cost for the tour is C dollars. I'm going to say the cost C is equal to 75x plus 90y, based on what they told us here. $75 for one car, so 75 times x is the cost for the cars, and 90 times y is the cost for the vans. If we're operating here, A, 9 cars and y vans, I'm going to test it now. Test. So see which one is minimum. A, which is 994. The cost at A, you're going to plug the x inside here. It's going to be 75 times 9, and plug the 4 inside here for the y, because there are 9 vans, plus 90 times 4. And work that out. And then if you're testing B, which was 66, then the cost at B would be 75 times the 6 cars, $75 times the 6 cars, plus $90 times the 6 vans. You wrote that out. And it's a matter of calculating and see which one is, what those values are, and see which one the lower one is. Which one is the lower one, right? So let me work it out on my calculator here. I can bring up the calculator and show, but I can just work it out. So it's 75 times 9 plus 90 times 4. I'm getting 1035 for this one. And if I do the 6 and 6, it will be 75 times 6 plus 90 times 6. And I'm getting the 990. So you see, this is a minimum to carry the same 60 persons. So you see, show that it is $90. So it is right here. So I'm going to tick right here and say, therefore, $990 is the minimum. When is it minimum? When they use 6 and 6, right? And 6 cars and 6 vans, or minivans, I must write vans, are used. When they use 6 cars and 6 vans to carry the 90 persons, to carry the 60 persons, they will minimize. If they use this combination to carry the same 60 persons, they're going to end up paying this amount of money. But if they use this combination to carry the same 60 persons, they're going to spend this amount of money. So the company wants to maximize on the amount of money that they charge. Then they're going to use this combination to carry the 60 persons. But the persons who are renting might look into it and say, okay, based on those fees and rates, we want to minimize the amount that we pay to carry the same 60 persons. So they're going to rent 6 cars and 6 vans and carry the same 90 persons, right? They're going to rent 6 cars and 6 vans and only pay $990 and still be able to carry 60 persons on the tour. But the company who is renting the cars, the vehicles, will want to use this combination because they want to get more money. So they want to say, okay, we will give you 9 cars and 6 vans. And if the persons who are renting are not checking, we say, yes, okay, 9 cars and 6 vans will pay $1,035. But if somebody among the persons who are renting the vehicles can do the mathematics, and that's why we need to learn mathematics, guys. This is a real life application of when mathematics is useful in real life, because the company who is renting the vehicles, they are going to offer you this. They're going to offer you that. And if you don't know, you'll say, yes, that will work. that will fit the 60 persons, and you don't realize that, yes, you're fitting the 60 persons, but you're paying more. If you know your mathematics now and you can do linear programming yourself and put the combination that the company, based on the information from the company, then you will know that to minimize the amount you pay to get the same 60 persons on the trip, and you want to minimize the cost, you will go and rent 6 cars and 6 vans, and you are still able to take the 60 persons on the trip, and you will only pay $990. And that's why in the class I say it is to maximize profit. So here the company want to maximize profit or to minimize cost. Here the persons who are renting the vehicles want to minimize the cost. That's what linear programming is all about. Maximizing profit or minimizing cost. It all depends on which side of the fence you're on. If you're on the side of the fence that is renting the vehicles, you want to maximize profit. So you go for this combination. If you're on the side of the fence that is spending the money and renting the vehicles, that these are the persons renting the vehicles now, they want to minimize the cost by doing this combination, and you still get the 60 persons on the trip. This is our example of how mathematics is useful in real life. A lot of the times we spend more money than we have to do things. But if you understood maths and understand the application of maths, right, then you can actually spend less money and get the services that you want and get the right combination for the service that you want. So this is, people ask me all the time, how is mathematics useful in real life? This is a good example of that. This is absolutely a good example of that, how mathematics is useful in real life. Some might have, why am I learning linear programming? Oh, I'm going to use this in a real life. This is an example. This is a good example of that. All depends on which side of the fence you're sitting. All right, everybody good? Everybody okay? But all right.
Yes, sir.
This is one example I'd advise you to go and redo. This is one example I'd advise to redo, because you know the way or they spin this question a little bit differently from the others. Sometimes they just ask us, what is the minimum and what is the maximum? But this time now, they paint a particular scenario for you. And you have to apply the mathematics to the specific scenario of having exactly 60 persons go on a trip. And see, the second part says, for this tour, for this particular tour, for this particular tour. All right, so that's what I like about this question. This one drilled down to a particular situation, and you're using the mathematics on it. I like that about this question. All right, so if everybody good, we're gonna do one more. What time is it now? How long have we been going? We're gonna 2 hours yet? No problem. We still can do more maths equal better maths. So we're gonna do one more still, even though we might go over the 2 hour target I want to have for these sessions, but let's do another one. All right, that's the nature of some of the classes and some of the topics, because we want to spend time and get the full understanding rather than rush through to meet a time. All right, so let's do another one. There's another one on 2021. I see I'm doing recent questions, guys. I'm doing exam questions from recent papers. All right, so you see the way the questions are set in the more recent times. This is another one right here on the screen. Let's look at this one. Everybody good so far with that one? So far, everybody okay?
Sir, my brain tired.
Yes, sir.
Brain is tired.
I'm not hearing you.
Brain is tired, sir.
Your brain tired? So let me ask you a question. You want the brain tired now? You want it tired in the exam? You have to make your brain tired now so that these things become easy in the exams. Push your brain now, because I don't want your brain to be stressed in the exam. So stress your brain now so that your brain will be relaxed in the exam. We're preparing for an exam. All you need to do is after this session, you take a break, you rest. You go back and you take your time and you go back to the video. You take your time and you go back to the video. Listen, it don't make any sense your brain stress after 2 hours, you know, because your exam is 2 hours and 40 minutes. You're preparing for an exam that is 2 hours and 40 minutes. So if your brain is stressed now, after 2 hours, you have to learn how to have your brain in a state of not being stressed after 2 hours. And the way to do that is to practice through that stress. Practice through that stress, because you want to be able to focus and concentrate for 2 hours and 40 minutes in an exam room. And so you have to train yourself to do that. And that's why my sessions, generally speaking, go past 2 hours. And when we get closer to the exam, they're going to be more than 2 hours and 40 minutes. You have to learn how to focus and concentrate, right? For more than 2 hours, 40 minutes, because that's the length of your exam. All right, so you have to work through the stress, guys. You have to work through the stress. So let's do one more. There's always time to go, but the good thing about it that the sessions are recorded. You can go back and take your time, go back to the video. When your brain is more relaxed, the information will be there in the video just the same. And so with your brain unstressed, you can still capture the information that I'm putting here. All right, but you have to just work with it. That's how you learn. When I used to study in school, when I started out studying seriously, I couldn't study past 15 minutes. I could not study past 15 minutes. I was tired, brain locked down after 15 minutes, and I continued, push past 15 minutes. Eventually, I could go 20 minutes. Then eventually, I could go 30 minutes. I mean, really focus studying. Then I could go 30 minutes. Then I could go 45 minutes. Then I could go an hour. There comes a point where I could study all day and remain focused for the entire day and night. So it's something you have to train yourself to be able to do. And when you get to university level, that's what you'll be able to, that's what you'll have to do in university, if you plan to do university, especially if you plan to do some of those top professions like medicine and engineering and chartered accounting and all these things. You have to be able to focus for a long, lengthy period of time and really stay focused and do what you're doing. You have to be able to focus on the same thing for an extended period of time. Even in the work world, you have to be able to focus for an extended period of time, and that practice and that training starts from now. Understand? And we are preparing for an exam for at least 2 or 40 minutes. So you have to be able to focus for that length of time, guys. So you have to bear with me and bear with the work. I don't have to be doing this. I'm doing it for you. I don't have to be doing it. I can shut down the class and go in my bed and sleep. I'm tired from being jet lagging from traveling, but I'm prepared to do this for you. All right. So let's do this. Let's do one more question, and then we'll call it a day. And I hope and pray that you'll go and take some time, relax, and come back and redo the questions, because you're preparing for an exam that the questions will be of this level. This is the level of difficulty of the questions. You have to get comfortable with them. You don't want to have to go into in an exam room and have to be thinking through these things. You want to be able to see the question and know what to do, and don't have to figure it out in the exam room. No, you don't want to have to figure these things out in an exam room. There's no time for that. You want to know what to do. Once you see the question, you know what to do. That's how you complete an exam and get straight A's, by knowing what to do long before the exam. And this class is about preparing you for an exam. That the aim is for one with straight A's. All right. This question says, Marla buys 2 types of mobile phones, B Flex and C Flex. I'm just going to call it B and C, right? Let's keep it simple, B and C. There are 2 types of phone for a company to retail. One B Flex phone is for $60, and one C phone is for $80. All right. So buy X of the B phones and Y of the C phones. So let's simplify it and call it X and Y. All right. So let's put it up here. So we should buy XB phones. Let's call it XB phones, because the B Flex and the C Flow and all it can confuse us. All right, so let's call it XB phones and YC phones. All right, so X is the number of B phones, Y is the number of C phones. And I'm keeping it simple. I don't want to confuse myself with this B flow and C flex. It's too much. So X is the number of B phones, Y is the number of C phones. What they said now is $60 for a B phone, right? A B phone is for $60. I'm gonna put the 60 right here. $60 for a B phone, $60. And you can write an exam paper as I'm doing here now. It's for your notes. There's no, you know, won't be penalized for writing on the exam paper. I'm just writing these to extract the information. I don't have to be searching for it in the wording again. $80 for a C phone. I'm gonna write $80 here. All right. It says Marla spends no more than 1,200. So no more means less than or equal to 1,200. So the total money that she spent, Marla must not spend more than 1,200. She can't spend more. She can spend 1,200 or less. So this product is a cost for the XB phones, and this product is a cost for the C phones. So the total money she's spending is 60x. Let's write it in blue. Sorry, let's write it in blue. The total money she's spending is 60x. That's for the B phones. Plus 80y. 80y. That's for the C phones. Has to be less than or equal to the total that she's prepared to spend. She can't spend more than that amount. Less than or equal to 1,200. That's the first inequality. It says right and inequality represent this information. So this is the same kind of stuff. All right. And this is going to simplify this. First, we're going to divide 2 by 10 and get 6x plus 8y less than or equal to 120. And then we can divide 2 by what? We can divide 2 by 2 and get 3x plus 4y less than or equal to 60. I think that's it. I think we can't go any lower than that. So we could have just divide this by 20 and go from this to this. But no problem if we go step by step as well. But good at that? But okay with that?
Yes, sir.
All right. So
Yes,
there's
sir.
1 mark for that, you know. But you know, that's it. It don't matter what it's 1 mark for. All right. So sometimes it look like the mark is too few. Sometimes it look like the mark is too many. But everybody's getting the same thing. All right. Next question says the number of B phones. Remember the B phones was X, right? Let's mark it. Number of B phones is X. Must be greater than or equal to the number of C phones. The number of C phones, which is Y. Not Y. That's what that is saying now. The number of B phones, which is X, must be greater than or equal to the number of C phones, which is Y. Write down and equal to the X and Y for this information. So that information is X is greater than or equal to Y. Now listen now, I don't like when Y is on the right side of my inequality. Because remember, this inequality sign is telling me whether I want above or below the line. But when the Y is on the left side, over here, on the inequality, the less than means below and the greater than means above. So I'm going to turn this around and write it instead as Y less than or equal to X. It's the same inequality, you know, but I'm reading it from right to left. If I read it from right to left, this is what I'm going to get. But understand that? Because I want the Y to be on my left side so that my less than means below. Because if you draw the line and you read this as a greater than means above, you're going to get the wrong side of the line. But understand this now? But understand that?
Yes, sir.
It's the same inequality, but I prefer to write it like this so that the less than means below. I want below the line. I always want the Y value to be on the left side and be positive. So I know for sure that the less than means below. All right, I want to put it together shortly. What else is there? It says represent only two. Represent the two inequalities on the grid. Label as R the region that satisfies both inequalities. All right, let's go. So what are we considering for the two inequalities? Let's put it in purple. So the Y over here is positive. So this less than means below. Let me write it here. So I want below The equals are part of the inequality, so I need a solid line. And the line associated with this inequality is 3x plus 4y equals 60. Again, I need 2 points on this line quickly. I'm going to put a value where the y, put a point where the y value is 0, x value is 0, put a point where the y value is 0. If the x value is 0 right here, that is eliminated. 3 times 0 is 0, and I'm now left with 4y equals 60. If 4y equals 60, 60 divided by 4 is 15. Is that correct? 15. Better good at that?
Yes, sir.
Good. And at the point where y equals 0 right here, like I cross that out, I'm left with 3x equals 60. If 3x is equal to 60 divided by the 3, I get an x equals 20. 20. So these are 2 points on this line, 0, 15, and 20, 0. Then I come to this line now, which is an easy line, y equals x. So less than means below, whatever is positive, less than means below. So I'm going below this line as well, below. The line is solid because the equal is there. I'm going to draw a solid line. And the line associated with this inequality is the line y equals x. And that line is one of those easy lines, again, pass through 0, 0, and pass to a point like 10, 10, or 20, 20, or 15, 15. So those are the two lines I'm drawing. 0, 15, 20, 0. This one first, pass through those 2 points. 0, 15, and 20, 0. They grid it up first already. 0, 15 is right here. 0, 15. I think this question another error in terms of the scale. You know? I think this question another error in terms of the scale because I put 5 right here between 3 lines, so, right? And then I put 4 lines again up to this. Let me see if there's an error. I remember sometimes I have some error on these questions. And then 1, 2, 3 lines again to that. Sorry. And then now, okay, now 1, 2, 3, 4, 5 lines up to that. So that's an error. I remember this question. So they made this mistake. So really and truly, if these 4 lines, these 4 spaces, take him up to 5, and then 4 spaces, take him up to 10, and 4 spaces, take him up to 15. There's 4 more spaces, should take me up to 20. So the scale of the graph is erroneous, right? Scale of the graph is erroneous on the y-axis, and then down here now, we have 4 spaces taken up to 20, up to 5, 4 spaces taken up to 10, 4 spaces taken up to 15, and 4 spaces taken up to 20. So the 20 on the y-axis is at the wrong place, guys. That's what I'm saying. 20 up here really should be here. Let me mark it out, right? 20 up here really should be here. If you recognize the mistake, right? If you recognize it, you have to be mindful that they do make mistakes. That's where the 20 is supposed to be. And if it is clear, that's a mistake, but when you understand what you're doing, you will know for sure. That's where the 20 should be. All right, so let's continue now, though. So it's 0, 15, and 20, 0. 0, 15, and 20, 0. Let's put it down in blue. 0, 15, and 20, 0. Human being do these things. 0, 20, 0, 15, and 20, 0. So 0, 15 is right here. And 20, 0 is right here. All right, so let's mark them. 0, 15, 20, 0. So you want the line to those 2 points, right? So you're going to use this ruler and draw that straight line down there. And then you label the line with the equal sign. So maybe I'm skipping some points up here that I'm supposed to pass through. I'll figure it out just now. So you label the line with the equal sign, which is 3x plus 4y equals 60. 3x plus 4y equals 60. 3x plus 4y equals 60. And then we want below this line, put arrow below it. All right, so we want below that line. 2 lines going to meet at that point. The next line is y equals x. So that line, y equals x, I'm going to see where possibly it should pass. Must pass through 0, 0. and must pass through 1010, which is right here. All right, 1010, no, sorry, 1010 is right here. So it looks like this is a point that the two lines pass through. So it passed down the middle of the graph like this. That's y equals x. Y equals x. All right, and you want below this line as well. All right, so you want below the two lines, and all the two lines you want. So region really then enough. I remember also is that the number of each item also has to be greater than 0. I can have negative number of things. So this is also a line. This is also a valid line. So the region that you want below those two lines is here, down to the x-axis. All right, and two lines meet at this point. But let's see what else I want us to do. Let's see if this point becomes valid on the question, right? Because that point would have to work it out. So what values those are. But let's see what else I want us to do. But that is the region. Also, must leave it as R, right? They didn't have to shade it. Leave it as R, not to shade it. So R is inside here. Mark it in a different color. Mark it purple. R is my region under here, below the two lines. It's below the two lines. Wait. Yeah, below the two lines. Below this one, and also below this one, right? That's my region. Let's make sure. All right, so we label the region. What does it want us to do? It says the total number of mobile phones is x plus y. It says, according to the graph, what is the largest possible values of x plus y? What's the largest possible value of x plus y? So you have to go to the vertices, right? You have to go to the vertices. So the number of phones, the total number of phones is x plus y. Let's call it t for total. Is x plus y. So that x plus y becomes maximum of one of the vertices. And I want to know what the largest number of phones. Remember, it's going to be at the vertices, right? And there are 3 vertices. So one vertex is this, 0, 20. No, 20, 0. And that's another vertex. What is that vertex? It's not 10, 10 enough. Right? It's not 10, 10. So what is this value right here? That is the question. What is that value? All right. So let's see what that value is. And if I remember, if a vertex cannot work, you have to go along the side. You have to go along the side, right? So I don't think there are any whole number of values of x and y that I can get along that side. That's what I don't like about this question, you know. If it was scaled differently, then you could know for sure what the points are. That's what I don't like about this question. This was not a kind scale to use, all right? Because like you have to divide now each of these. You have to divide the 5 by 4 because there are 4 spaces in here. There are 4 spaces in here to know what each of these marks are. Each of these marks. So you divide the 5 by 4. The 5 total space by 4 to know what each mark is. Each of those marks. All right, so 5 divided by 4 is 1.25. So this is like 1.25. Then this is 2.5. And this is 3.75, which you really can't have 3.75 phone, because if you look at this now, this would be adding 1.25, this would be 6.25. Then here would be this would be 7.5, and this would be 8.25. That's what this point would be, 8.25. We're going to test it now. If this point is 8.25, 8.25. Let's test it on the equation and see if it works. 8.25, 8.25. 8.25, 8.25. All right, we're going to test it on this equation right here. So it will be 3 times 8.25. If the scale was better, it will be easier. So I don't think they really intended for it to be that scale, you know. 4 times 8.25. I'm just testing it to see if it works. Let me bring up the calculator on the screen so you can see. I think they didn't intend for the scale to be what it is. I think they really want it to be 1 centimeter to 1. So you could actually see the points more clearly. All right, let me see and show you. And this happens sometimes in 6, and sometimes actually disregard a question, or because of these things. So let me test it out. It says 3, it's 3 times 8.25 plus 4 times 8.25. How did I put that plus right here? So that doesn't work. So that point is not correct. I do have the right point. 6 plus 4, 8. But I'm supposed to get 60. So that is not 8.25. I'm going to double check that. Oh, 8.75, not 25, 8.75, 8.75. So it's a good thing I'm checking. 8.75. Let's change this to 75 and change this to 75. Still doesn't work. Wow. All right, let's make sure. Hold on. That's what happens when the scale is not friendly. It's not a friendly scale. All right, so let's just double check. This is 4 spaces. 1, 2, 3, 4. 1, 2, 3, 4. 4 spaces up to 5. So it's 5 divided by 4. 5 divided by 4. Let's do everything. 5 divided by 4. That's 1.25. All right, let's count how many we have up to that point then in total. So it's 1, 2, 3, 4, 5, 6, 7, 7. So 7 times 7 times 1.25. So it's 8.75. So why is it not working on the line? But maybe that is not the point, because it's supposed to be 3x plus 4y equals 60. 8.75. 3x plus 4y equals 60. So that is not a valid point. 8.75. 8.75. 3x plus 4y equals 60. Right? So it will be 3 times 8.75 plus 4 times 8.75. And we're not getting 675. We're not getting 60. So not 8.75. That is not a valid point. That's the thing with this question, guys. So that's not a valid point. That point is not on the line. That point is not on the line. So you know what? I'm gonna do over the scale. Let me do over the scale rather than fight up with it. Let's do over the scale. That's how it is sometimes. Let me do over the scale and put the scale at 1 centimeter to 1. Make it work itself out better. So I'm gonna mark these out and do over the scale. But that's not a valid point. I'm depending on the graph to give me. I can solve equations simultaneously. All right, and get it, but let's do over the scale and make it a more friendly scale. And this happens sometimes in CXC. And this point won't be valid either. Let's do over the scale. I'm going to make it 1 to 1 and see what happens. So I'm going to do 1, 2, 3, 4, 5 right here. 6, 7, 8, 9, 10 right here. 11, 12, 13, 14, 15 right here. Just that I'm not going to have 20 to work with, right? But okay, it's another point still, no problem. Here I'm going to do 1, 2, 3, 4, 5 right here. 6, 7, 8, 9, 10 right here. And 11, 12, 13, 14, 15 right here. All right, let's use those points instead. All right, so the line now, we're going to pass through 5, 5. The y equals x1, 5, 5, and 10, 10. So that first line, y equals x, is going to pass down the middle right here. All right, so it's going to pass right down the middle. Like that. And then the other line, which was, we need to find another point on it. So this other line passed through 0, 20, and 20, 0, but we don't have the 20 on the x-axis to use. We need the 0, 15 for sure. Let's make sure the 0, 15 works. So put in 0 here. We're going to get 4y equals 60. 4 times 15 is 60. So that is correct. Right? 4 times 15 is 60. Right? So 0, 60 is correct. Right up here. 0, 15 is correct. Let's put in 10. So we have 3x. We could do another thing. Let's do another thing. Let's put it in the form y equals mx plus c. So it will be 4y equals minus 3x plus 60 divided by the 4. We get y equals minus 3 over 4 x plus 15. So we can use a gradient. So this is the same as this the rise over run using this one. If you use up your full knowledge is minus 3 over 4, which if you multiply by 10 will be minus 30. Well, not 10, 5. If you do 5, we're going to get 15. And rise 3 run 4. Rise negative 3 run 4. So starting here, we can rise negative 3 run 4. So rise negative 3 run 4. So we can go like this. Rise negative 3, 1, 2, 3, 1, 4, 1, 2, 3, 4. Get to this point. Rise negative 3, 1, 2, 3, 1, 4, 1, 2, 3, 4. Get to this point. Rise negative 3, 1, 2, 3, 1, 4, 1, 2, 3, 4. This point. Rise negative 3, 1, 2, 3, 1, 4, 1, 2, 3, 4. Get to this point. So those are points on the line. So you see, it's a line that passes through exact values. So it will go like this. That other line will go like this. All right. So the question is, where is this point? Remember on the original graph, it passed through 20, guys. Remember it passed through 20 out there. Remember it passed through 20 out somewhere out there. So we're not losing sight of that, right? Just that the question is not very friendly for testing this point. All right. But we have these points on the line that we can use. Not a very friendly question, but that's how it is. So shading under here still. Still shading. Oh, this I must put an R. I think we have to put an R down here. Shading under here still. That will be the region that we want still. But question is, what is this point? What is this point right here? All right. So how do we get that point? Now the question now is, what is one of these little lines? Because this now is 1, 2, 3, 4. So there are 5 lines, small lines now between 0 and 1. So it means that one of these little lines is 1 out of 5, which is 0.2. Right? One of those little lines is 0.2. All right. And we're trying to get this point right here. So if we zoom it up, remember this now will be 5, 6, 7, 8. This will be 9. All right. So right here is 8. If we look at it, it's like 8.2, 8.4, about 8.6. All right. Let's call it 8.6. All right. So this point would have to be about 8.6. 8.6. Not going to be exact. I can tell you from now. It's not going to be exact. To get it exact, we would have basically solve the simultaneous equations and see what is it. So let's try 8.6 over here. So 8.6, 8.6, 8.6. We get 60.2. It's not going to be exact unless they get it at a decimal. It's not going to be exact. But this is 8.6, 8.6. Right? Now watch me now. I don't think there are any points. Let me say this point right here. I want an exact number of phones and an exact number of phones. You want exact values. So this vertex cannot work. You need a point with exact values. We know that the vertex over here is 0, 20. So you can get 20 phones there. So this point, for example, would be 10, 11, 12, 13. So this point looks like a point that can work. This here will be 6. So this point would be 12 and 6. So on a side, so it's going to give us 18 phones. So the answer is 0, 20, out of the vertex, Because up here is 16 given us, 16, 8.6 and 8.6. And you cannot use the vertex, so you have to come along the side. The first point along the side that could work is here, or I could go along this side. This point would be 8, and this is 6, 7, 8. So it would be 8 and 8. Right here is 16. 8, 8 would be 16. 8 and 8, which would be 16. Right? And over here giving us 16 as well. But remember, the vertex down here was giving us 20 and 0. So it looks as if what they wanted, the largest possible. So that would be 20. The largest possible value would be 20, x plus y. It will be the point 20, 0. 20, 0. So it's 20 of one plus 0 of the other. So it will be 20. I mean, that took a long time to do it. It's only 1 mark, but I just wanted to make sure because, especially because the scale was not a friendly scale. I just wanted to make sure. Bottom line is that you're going to get at a vertex. And the vertex that was giving us the largest value was the one down on the x-axis, 20, 0. Right? Because this vertex up here, even with the example that we did, it was 8.75, 8.75. That we're estimating it to be. So 2 times 8.75 is still giving us a value that is less than 20. So the vertex was the one out here that we did originally, which was 20, 0. That gave us the maximum. So the answer is 20. All right. Sorry it took so long, but I just wanted to make sure, based on the unfriendly scale that was presented with this question, but you have to work with what is given. But the answer is 20 at the vertex down here that we did out at this point. But understand that?
Yes, sir.
All right. So the answer is 20 based on the vertex that was on the x-axis. Remember, initially, we had this. I'll sketch it out for you. One line was y equals x going like that. The other line was like this. And this is the y-axis, this is the x-axis. And we're working with these vertices. The out here was 20 up here. And we want it down here. The region I want is down here. So this vertex was 8 point something, less than 20 when you add it. Because on the scale, we're getting something like 8.25, 8.25, but it's really 8.6, 8.6. You can't have 0.6 phones, right? 8.6, 8.6. When you add up that, it still don't reach 20. So the maximum you can get is at this point right here, the maximum total for x plus y is 20 out there. All right, guys, so I'm going to stop it there for today. This question wasn't friendly because of the values at this point in particular, but it still kind of makes sense, right? And the scale kind of mess up the scale on the y-axis, but no worries, work with what you have. And it's always good experience to do these questions. See the trouble in them, some of the trouble in them, and realize that it's only 1 mark. So you see the question really just came down to this vertex, but I just wanted to make sure, especially with the point up here, that I wasn't getting exact values. Just wanted to make sure. All right, so that is it for today. As I've always said, go and redo the questions. Right? Go and redo the questions. And you will learn and improve at a much faster rate the more you practice. All right, guys, so that's it for today. Now we're moving on to a new topic. This week, remember the classes this week are all online because I'm not there. So all the classes are online. And we're starting a new topic, going into a new phase of topics, which is matrices, transformation, and vectors. All those topics are kind of related. matrices, transformation, and vectors. We're doing matrices first, then transformation, then vector. But this week we're going to do some revision. What I'll do is send a revision document to you guys to look at, and we address it in the class. All right, bye everybody.
Bye, sir.
All
Bye,
right, I
sir.
think we went about 2.5 hours today, but that's okay. Bye bye everybody.